life's a grind, but there's no regret. Just build, 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 let your heart connect. I love you and you matter, never forget. Oh, free, they're leading the way, pushing the limits, redefining the play. For the crew, for the tribe, for the ones who strive. He's the pulse of the maker's drive. Yeah, he's setting the tone for every designer, making magic their own. Blueprints and dreams, they're the tools of the trade. With free Heathen Workshop, the future's made. His models are art, his passion's the key. He's building a world for the community. Through struggles and triumphs, he's always on deck. With the mantra he lives by, protect your neck. So keep your chin up, protect your neck. This life's a grind, but there's no regret. Just build, 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 let your heart connect. I love you and you matter, never forget. Oh, free, Heathen leading the way, pushing the limits, redefining the play. For the crew, for the tribe, for the ones who strive. He's the pulse of the maker's drive. It's more than print, it's a way to rise through the sweat and tears under burning skies. He's here for the makers, for the love he gives. With every design, he shows how to live. All free, then leading the way, pushing the limits, redefining the play. For the crew, for the tribe, for the ones who strive. He's the pulse of the maker's drive. So keep your chin up, protect your neck. Yo, it's free Heathen breaking the game. For the makers, the dreamers, remember the name. Crew and tribe, we're riding this wave. For every creator who dared to be brave. He's the man with the vision, designs that inspire, fueling the scene with relentless fire. From the crew to the tribe, he's breaking the mold, building a legacy that's fierce and bold. Promoting the makers, he's lifting them higher. Every model a spark, every print's desire. He's got the skills, the hustle, the drive. Free Heathen Workshop, keeping dreams alive. So keep your chin up, protect your neck. This life's a grind, but there's no regret. Just build, 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 let your heart connect. I love you and you matter, never forget. Oh, free, they're leading the way, pushing the limits, redefining the play. For the crew, for the tribe, for the ones who strive. He's the pulse of the maker's drive. Yeah, he's setting the tone for every designer, making magic their own. Blueprints and dreams, they're the tools of the trade. With free Heathen Workshop, the future's made. His models are art, his passion's the key. He's building a world for the community. Through struggles and triumphs, he's always on deck. With the mantra he lives by, protect your neck. So keep your chin up, protect your neck. This life's a grind, but there's no regret. Just build, 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 let your heart connect. I love you and you matter, never forget. Oh, free, Heathen leading the way, pushing the limits, redefining the play. For the crew, for the tribe, for the ones who strive. He's the pulse of the maker's drive. he shows how to live. All free, then leading the way, pushing the limits, redefining the play. For the crew, for the tribe, for the ones who strive, he's the pulse of the maker's drive. So keep your chin up, protect your neck. Just build, 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 let your heart connect. I love you and you matter. Hear the call with free heathen. There's room for us It's free heathen breaking the game. For the makers, the dreamers, remember the name. Crew and tribe, we're riding this wave. For every creator who dared to be brave. He's the man with the vision, designs that inspire, fueling the scene with relentless fire. From the crew to the tribe, he's breaking the mold, building a legacy that's fierce and bold. Promoting the makers, he's lifting them higher. Every model a spark, every print's desire. He's got the skills, the hustle, the drive. Free Heathen Workshop, keeping dreams alive. So keep your chin up, protect your neck. This life's a grind, but there's no regret. Just build, 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 let your heart connect. I love you and you matter, never forget. Oh, free, leading the way, pushing the limits, redefining the play. For the crew, for the tribe, for the ones who strive. He's the pulse of the maker's drive.
Good morning, good afternoon, and good evening. Welcome to the Free Heathen Workshop. My name, of course, is Maker Millwright. How are you all doing? Welcome into the YouTubs. Yeah, get a little active in that YouTube. Remember, like, subscribe, upload. I don't know. There's a bunch of stuff. I hope you're all doing well. I know I'm excited to be here. I originally wasn't super excited, but I am. Hello, Jupiter. How goes her? Thank you for the follow. I appreciate that. So you can see there's new tanks. I still haven't released those, so I probably should do that today. I don't know if I want to work on the new tank. The new tank is pretty close to release. Probably another hour, maybe. I kind of want to work on some stuff from the Bambu box, but I don't know if there's any renders. Right? So we got the Bambu box, and I am tempted to try and make some parts for the, what was it, the 90 degree? 25 RPM? Do we want 25 RPM? What do we want? 1000 RPM? Yeah, probably don't want that. 400 RPM. I thought there was like a 60? 50 RPM? 130 RPM? Servo with clutch, but we don't need that yet. What's this? This is the M20 M3 by 25 threaded reduction shaft. What's this? I don't think I have any nuts in here though. And we have round magnets. Maybe we're stuck with the 100 RPM? I thought we had a 60 RPM. Was I wrong? 130 RPM. Dual, what's this? Dual? Dual output? Dual. Could be fun. Because what we could do is, I was thinking about making a paint shaker. There's a couple of ways to do it. There's one with a shaft where the main sits on a shaft, and then we gear it. Although gearing in Tinkercad is not the easiest, I'll be honest. We can try it. Yeah, so this is definitely a dual output shaft because you got shafts on both sides. They're really small though. They should be pretty beefy, but they're small, you know? Light on, I can't see. Everything is too dark. So, I think we're gonna use the 25 RPM. It's like 1 revolution per second, right? No, not even. It's 1 revolution every 2 seconds, so it's pretty slow, but that's pretty fast. Cause like when you put it on a cam, I'm not sure. We got the motor controller. No, what do we got here? We got a single axis. Is this just? Let's see what we got here. So we have this one, right? We got the motor controller. We got the USB controller. We got all the fancy stuff. But let's just take a look at this. I know I didn't change the title correctly, and I don't know where all the mods are. I don't know if we're even gonna have mods today. But let's take a look. So what I'm looking at is this. I already put the power to it. So this is just straight up USB. But you could just build off this. Because I know I have another one of these from KB3D. Could just measure the shaft. And then, well, that's why I left the Bambu open today. So maybe we'll start with that. Let's do that, right? So we're not worried about the mounts yet. We're not worried about anything like that. Let's just see if we can do the wheel. So we'll do a wheel first, and then we have to put a hole in it, or put a screw hole in it, or there's a bunch of different things we have to do to get it to work. Um, So I need my calipers. So the first tool is you're gonna need a set of calipers, right? Like that's just the A1 number one tool when you're doing this stuff. You could use a micrometer, but people have problems with micrometers. Like micrometers, mics are good, like they are. Um, digital calipers are not. Everyone recommends digital calipers because of easy use, but they're not actually super correct. Nor are these shafts, right? Because like they're not high precision. It's normally why they're made out of metal, because it's more high precision, because you can align your positions correctly. But yeah, so we got the new tanks there. I gotta do something with them. I should probably release them, but I've been lazy. So let's go and open Tinkercad. So we have Tinkercad open. I'm gonna go here. So I think the first thing we do, I don't really want to do a render of this, but I think I'm stuck doing a render of the motor. Don't know if don't know if there's been a render done already. It does have a screw hole, so we could mount it to a base. I'd rather just not do this though. 22, so 22.5. Box 22.5. And then, so because you can see the motor, it's got a round part and a square part. It does have that domed corner piece. We're not worried about that. We can figure that arc out if we really want to, but we don't have to. So let's say 37 mil. So it's 37 mil, and then we have to add the motor assembly, if that makes any sense. Now, the easy way to do that, I don't know if there's an easy way to do that. I don't know if there's an easy way to do that, but let's just say 28. So we need one of these as 28, so we'll make it 29, and we'll move it in 1 mil. So we'll rotate to the side. Then we'll do a length of 29, right? Because it gives us 1 mil, we'll jam into the object. And then we'll just determine the round. We won't determine the round based off the motor, we'll determine it off the housing mounts. Looks like, to me, it's 22.3. What's this one? 20. So it's going to be a little weird because we have to move it down. So 22.3, what does I say? Because you see these little tabs here. There's little tabs on other sides, so you can remove the motor on the motor. Could just do the cylinder and then measure out them. So it's also 20. So let's say it's 20, and it's 29, so we come over here, we're going to align to that face, right? And then we're in the ones position, move it in 1, right? And then we can align centers. But there's a couple of things else we can do. Like, for example, there's a screw hole on the end of it. So we probably want to determine the height of the screw hole. There's a couple of ways to do this. So this says is 8 point, to the top of it's 8. So that's a good sign. So I did that wrong. But anyway, so we got 5 by 3. So 5 wide, 3 tall. I said it's 3 tall? Yeah. Go in here, 3. And then we're going to... Since when did Tinkercad make noises? I've never... And then we're going to go for a width. Say it's 5. It says 4.9, but we'll just go to 5. And then we know it sticks out a certain distance, right? So that's when we take our calipers and we line up. So it sticks out 4.8. So we'll go 4.8. Go 5.8. And then what we'll do... Hey, Sean, how are you? So we'll come in, right? We'll come right up and we'll kiss the surface of the object, right? Just like that. And then we're going to go in 1 mil. Now, we do have a hole in the center of that, so we should probably do something about that. But the hole is, what's the diameter of the hole? Can we get to that? So it's a 3 mil hole. And then we'll have to measure the distance. So we should take this, make this 3 mils. And depending on your extrusion values and stuff, and then it is 1 mil from the outside edge. So come to the outside edge till we match up to the very outside edge of it. Easiest way to do that is come here, align. I still don't have a tool per se that kisses the face for some reason. Hey CGS, how's you? And then of course, we want to be aligned center, right? So like that, right? And then that's fine, right? This should definitely be a different color. Make it green. Because if you don't make them different, you can get confused. Now, we want this to come up to the top. And we're going to come down to 8. We're going to come down 8 mil, okay? So we're going to go up here. And then because the snap tooling doesn't allow you to, it only allows you to move the 2D plane, we're going to come down 8. One more. There we go. And we'll just measure this. This box is actually 19 mil. And then measure from the top to the bottom, less the middle. We come down 8. Because 12 minus, what's the thickness of this? 3. 12 minus 3 is 8? No, that's not right. 9. Yeah, so it's not centered. It's actually a little bit higher than center, which is weird because it looks like it's centered. We'll make it centered. Actually, we can measure. So it's 7 mil from the bottom. That's easy enough. From the bottom, so if we go up 10 mil, so we just hit D, and we go up 10 mil, and that'll align us. Like that. And then again, like I said, this is actually 19 mil, not 20, 19. And then this this gearbox and motor assembly are all centered to it. Right? Which is weird because that now says, well, this has flats on it, that's why. So the flats of this will make it, so we have to take half a mil off either side. This is 0.5. And then we just have to come over here. Right, and we come along and we do that. See, it's going to take the flat off. This needs to be level. This and this grouped. This is level and this is level. Okay, and then, so because we know this is 0.5, so we're going to measure from the outside to the inside. We're going to copy. We're going to go to the top of this. top of this like that, right? And then we're going to group the three. Hit D, and there we go, right? So now we're flush, right? Because it takes half a mil off either side. Do I actually want to do the motor? I don't think I need to do the motor, but I do need to do the funny little tabs on it. So how big are those tabs? Do I kind of take this apart? Can. So the tabs are... Well, that's actually, there's an easy way to do this. There's an easy peasy way to do this. So that, remember, it's held in by like a rubber retainer. Like this. See that rubber retainer? It's like a rubber band. That's what pushes the motor in to mesh with the gears. Remember, you can take the gears apart. You can take everything apart, right? I thought there was gears in this box, but I didn't see any. Am I wrong? I think I'm wrong. We can hook a speed controller to this, but at 60 RPM should be roughly what we want. So we just measure. Just going to measure the heights of these two little tabby thingies. They're 22.3, so 22.5. So we take a little square. 22.5 just because. All right, and then we come in here and we measure the width of it. So it says it's 4.6. Let's see the side. 4.5. So we take the average, we'll go 4.5, right? Because it's probably me mismeasuring. So this ends up being 4.5, 4.5, right? And then we measure the width of the head because we're not worried about the band, so 3 mil. We're just trying to, just in case it ends up being a problem in our alignment issues. So then we come in here, we're going to go 3 mil. We just double check it, come in here, check that side. So it says 2.3, I was wrong, so we'll go 2.5 just in case, 2.5. Right, split the difference. Now we need to measure from the edge of the square to the front. Well, we could do the back, I guess. Because there's a little recess here. Yeah, which shows it there. Okay. Because this should be on the ground. Yeah. See how it shows there's a little edge? There's no edge there. Why is there no edge? This cylinder, it's saying it's 17. So maybe I'm wrong. So let's make the height of this 17. What's the width of it? How big is this box? 22. And this is parallel to the outside edge, so it should also be. So this needs to be 22 wide. Line center again. That's sort of what we're looking for. 17. So 17. This is 8. It says it's 8. What is here? This is 19. 18 point. That should lower that because we're worried about that little lip in there because we're gonna make a box for this to hold it, and then we'll put a wheel on it, and we could probably do the ring as well for the gear output. So that's our little flat, and then okay, so we're doing the tab first. So the tab is from edge to edge. .5. So we come to this, we take this here, which we need to change color of so we know what we're doing. Align it to this, right? Come in here, center, back edge, right? And then we're going to move it 7.5. So we go over, undo all what we just did. 7.5, and then we end up centering everything. Right? And then the little tabby has to come down the height of that. So we take one of the rubber band mounts off, and we just Measure. I think it just ends up being centered. It looks, yeah, it's 2.6, so it looks like it's centered. So, you know, we're just taking care of that little retainer, and then I guess we can do the motor, but I don't really want to do the motor. Okay, so this needs to come down, needs to come out the bottom 2.5. So we come down negative 2.5, 2.5, there we go. Okay, so that's now our motor assembly, okay? This 18 points, why is it 18.5? Keep telling me you're 18.5. So are you 18? Yeah, you are 18.5. This is 18.5. You are 18.5. So then this from the top, because there is a difference. Bottom, because that's the way Tinkercad. I think it's 12.5 down. So we need to come up here, line to the top, right? And align center. Come down 12.5. No way that's right. No way that's right. Because maybe it's not 12.5. What do we do it again? On 9. Maybe it's choosing the top face this time, so we're going to go -9. There. That looks about right. Yeah, that looks about right. Now we can do the cylinder length. First cylinder is 11.5, so this is 11.5. 12.5, 11.5. There we go. Okay, now we need to do the motor. I didn't really want to do the motor because I'm lazy, but we'll do the motor. So the motor has a diameter of 19.5. Can't do the squeak test on these. With micrometers, you can do the squeak test. 19.5. What is the diameter of this? 22. Okay, let's take another one of these. So we're gonna do a diameter of 19.5. So we take these, but we're gonna have to cut it because the motor is not particularly round. So then we know that the motor across the flats is 14.5. So when we turn this to its side, so the difference between 14 and 19.5 is 5, so 2.3. So we'll make the height of this 2.3. No, 2.5, right? 5. No, it's 14.5. Yeah, 2.25. Something like that. Then we copy that. So what we're going to do is we're going to align this to the center of this. And on the bottom of it. This one, and we'll do the same thing. Align center on center. So center, center, top. Right, so now it'll trim the motor. And then what's our length? 14.5. So we'll do that after we cut it. So now we're going to group it. There's our motor, and then this needs to be 15.5 because we're moving in 1 mil. So we just come in here, this. Change the color so we know what we're working with. Then we're going to come up base like that, and then we're going to go in 1 mil. And you say, but why, Maker? It's kind of a waste. It is kind of a waste, I agree. That's what we're looking at. And we do have that output shank, but I'm not worried about it. That gives us, that should be our motor construction, okay? Now, do we worry about the power cable? I don't think we worry about the power cable. So that's our, and then we need to find, so we need to undo all this, because we need to find where the output shank is. So first of all, we're going to find the circle. There is a 7 mil circle. This will be the base of the output shank. And we can kind of cheat because we can measure the height, the total height. So total height is 19.2. Injection molding shrinks, if you guys don't know. Okay. So this is how tall? 18.5? Yeah, this should be 19.5. Now we need to know how far it is from the edge. 14.6, so 14.4, more than likely. It's the outside. So we can come here, this ungroup, okay. Come here, take this, we'll align to this, right? We're from that edge, we can go, because we're going to be measuring, we are going to measure. So we're going to go 8 mil. Is that right? Did I say 8 mil? In? I'm not sure if this is right. 8. Whoops, undo. We're in the ones position. 1, 2, 3, 4, 5, 6, 7, 8. That looks right. Now, we have another cylinder that protrudes a little bit more. 20.5. So we take this, clone it, change the color of it so we know what we're doing with. That one, we go to the outside edge because we can mess with it a little bit while it's in the model. So we know the diameter of that cap is, I think 3.8. So it's 3.8 around. So this goes 3.8. Come in here, we just pick this, we go 3.8. And then we can go 3.8. Right, and then so we still need to be aligned center because it's going to be on the same axes as the drive motor because it's actually, that is the end of a shaft that holds gears. So then we measure from the edge, 24.5. So we take this and we move it this way and we're going to go negative 4.5. That looks roughly right. Roughly right. And then what did we do? Did we change the height yet? Did we? No, we didn't. So it's 20.5. Go. And then we're line center. Because everything's on center on this thing, right? Because it's injection molded. Do we want to do the screw holes? We could do the screw holes. I'm lazy though. Should we do the screw holes? I think we should do the screw holes. Did I put Tinkercad in the title? I should probably put Tinkercad in the title. What's this thing called? Apply? No. Where's the label? Show me the label. There we go. Again, I still need a bunch of boxes for all this stuff, so. Is it labeled? Is it just Maker Supply? Maker Supply parts, I guess. Bambu, Maker, Supply. Not parts, parts. Stuff, print and place truck. We're not doing a print and place truck. We are making Add build. Then I don't know. Can I call? I don't think I can call to my. What? No, I can't call to my Bambu stuff. So I can't call any. That's why I don't use YouTube. Uh, we're always looking for new people, but I don't generally use YouTube because I don't have all the bells and whistles I have over on Twitch. Oh, and then I did see that you guys posted some super awesome stuff. So what was I doing again? I forget. Oh, labeling stuff. Not Tinkercad, Tinkercad parts build. I need to put all my links into a PDF or something. Not PDF, but a thing, and then do the stuff, you know. So that looks kind of sort of what we got going on. The diameter of this is being weird though, I'll be honest. Almost looks like it's too big. Should be a, well, there is a rim. Why is this round? This should be 17, and then this should be, okay, it just looks weird. Alright, that's fine, whatever. It don't matter. But now we're doing screw holes. Oh, screw holes. I'm late. It's gonna be 3, right? Calipers all the way closed, and then get into that hole. Holes. Because when you standardize stuff like that, you just kind of get, when you're done doing this stuff a bunch of times, you end up finding like standardization. And then we need to measure from edge to the outside, 3.5, and so 0.7 from the edge. So we'll come in here, we'll do this, and then we'll edge. Move this in. 3 times, and then we'll take off the 0.5. One. Oh, that was a bad idea. So we'll come in here, and what are we doing? I guess 7 times. 1, 2, 3, 4, 5, 6, 7. Okay, and then from the outside corner, we are 3.5. Take this. We're okay where it's at, right? Align. And then easy doing it, putting the ones position, right? Selecting it. 1, 2, 3. And then we need 0.5. So we come in here, we pick the 0.5. 0.5. Okay, so there we go. So now we need to copy this, move it to the outside edge, right? So we should still be parallel. We haven't moved anything. We then go into the tens position, right? We just select this and we go over 7. 1, 2, 3, 4, 5, 6, 7. There you go. So that should be our screw holes. Yeah, it looks right. And then the only thing we're missing is the motor output. Now that one gets a little, okay, so I guess we can group these. So we don't want to lose these. Now typically you wouldn't group everything until you're done because you still might have to move some things around. But we're starting to get close. But see, I want to use this center circle because that center circle is like a protrusion from the casing for the shaft. So when we look at it, we got to look at the shaft, right? And we measure the outer diameter. So it says 5 mil, but then it's got flats on it, right? That makes it 3.5. So we're gonna make a shaft that's 5 mil. So we take this. Oh, we could actually measure the height as well. So let's do that. 27. 7. So we'll make this a different color. 27, right? And then we're going to make the diameter of it 5. You say, well, I don't understand. Well, because you're going to have to trim it, right? But we want to stay aligned to this cylinder, right? Because that's the output shank, right? So there we are there. Now, what we do is we got to shave the sides off it. So we know it is 3.5. So 3.5 from 5 is what? 1.75? Yeah, 1.75. So we need to take this, and we need to make this 1.75. And then what's the height of this? 27, so we might as well make this 27. So we align to the center of the cylinder, right? And then we're going to go to the outside edge. And that should trim it off. And then we're going to do the same again. Copy this. Go here. This should give us... And that looks weird. Is that wrong? What's the thickness of that? Right? 3.7. What is it? Tell me. 3.5. So, how big is this? 0.75. 1.75. I get a calculator. Hold on. Okay, 1.75 plus 1.75, 0.5. So why does that look so small to me? Because I can take another block and I can make it 3.5, and that can sit in the center of this. That's wrong. So, oh, I did it backwards. Okay, so 5 mil minus 3.5 equals 1.5. Ah, they're much too big. So 1.5 divided by 2 is 7.5, yeah. So these need to be actually, not that, these. These actually need to be 0.75. See what happens when you're not doing your math right, right? Happens all the time. So there we go. Why they dropped the Mars rover, right? There we go. So now we're skirting the edge of that square. So we know what we're doing here. If you're not sure, check your work, right? That's the, oh no, I checked my work. Okay, so there we go. There's no holes in it. There's a center hole in it, I guess. How big is this? Calipers might be too dull for that. That's 1 mil. Because it has to be a standard size, right? They're not going to make a weird size in the middle of something. But my calipers, they're too dull. That's a 1.5 mil diameter hole in the center of that. So we'll just make a 1.5 because that actually is a screw size. 1.5. Pretty sure it is 1.5. We can always, I think we can go check the build on this. I'm not sure. But this goes in the center of this. That looks right to me. There's our hole. Now I don't know the depth of that hole. I don't have, the tool I have is far too big to go into the hole. So we'll just make a deep hole in it. And if it is what it is what it is, right? So that should be, yep, everything aligned. There. How bloody long did that take? Ugh, that took like 30 minutes. Ugh, gross. Anyway, so there is our motor render. And then what we can do is we can turn this one color, right? Copy this, take this. So now we have some choices. Now, so now we have some choices. Do we make a housing for it first? Right, because this is not there, it's floating, right? So we need a housing at least to hold it. Do we make a housing to hold it first? Or do we just make a wheel to have fun with it? Knowing you guys, you're gonna wanna make a housing. So this is gonna be 2 mil. It should be enough. Yeah. All right. But then we gotta come out and we gotta make sure we're the same size as everything, right? But we probably want to come out more than that. So how wide is this? It's 22.5. So we probably want to add 4 mil to have 2 mil on either side. So 22.5. Let's just do 25 mil wide. That's too little, right? That's just too little. It's not going to be enough, right? Well, it might be okay. Check our alignment. See, I think that's not going to be enough. That's 1 mil per side. That's definitely not enough, right? So let's go and let's do this again. So 25. So this is how big? We're just going to put it in a pocket. Let's say we want, because we still have to leave a half a mil gap on either side. So we'll go 24.5. Because we can screw it in, but I don't want to screw it in if I don't have to. We can do that though. So let's 20 for 25.5, right? Nope, undo that. No, see, that's not enough. So let's do 28.5. That's not looking terrible, right? And then we got to come up high enough so that floats. So we can definitely take this. Second here, I gotta check my personal email. So I can put you guys on the AFK stream.
Dark trap beat kicks in later with gritty guitar riffs. Yeah, it's free heathen breaking the mold, pushing designs with a heart of gold. From things to printables, we light the way. 3D dreams on display every day. Started with a vision, now he's leading the scene. Free Heathen Workshop, living the dream. Design so clean, they're ahead of their time. He's breaking the rules, redefining the line.
Sorry, I had to check my personal emails. You know how it is. Sometimes you just gotta take a minute for yourself, right? So we probably want 1 mil clearance. So we'll make this 4 mil tall, 4.5. Right? But then we're gonna come down here and we're gonna find this. How do I want to do this? I think I want to do it the other way. I want to do. No, I did it right. Um. Oh, I know what to do. We take our magnet and we magnetize it to. If we can hit the right keys. Magnet this to that. There we go. Okay, so there we go. We're now sitting against the motor clamp mount, I guess you could say. And then we just come in here, we go 1 mil, and then we're gonna go down 1 mil. Whoop, 1 mil. Right? So now we're clear there. We now have everything sort of, because we got to put side panels on this still. And then we can come out here and we can do stuff like, we can put in another box or something, right, when we get there. So let's do, because we now know this is going to have to be the same height as this, right? So we come down till we meet that face. We're going too far. And we can hollow it. We can do a bunch of stuff, right? So this and this level. They are level. Okay. So we're not worried about this. We're going to change this to a different color so we don't forget about it, right? Now, this has to come out past that screw hole, right? For sure, for sure. We can put a little block in there, I think. We'll just come to the face of this. And then we're just going to come out half a mil. Half a mil. There we go, half a mil. And then this doesn't need to be so big, so we meet it on the face, and then we just bring it down until we've got almost touching there a little bit. Just because the extrusion might be a little tall, right? So we might have to file it or whatever. But okay, so there's our box. This, we can sort of do a thing where we come in here, up really big, and then come down small until we sort of make the same shadow diameter. Because we're actually going to have to be smaller than that hole for our screw to fit in. Because remember, our screw hole has to be smaller than the circle, right? Because you need something for the material to bite into unless you're using a nut, which we will not be using a nut because I am lazy. Come down, come down, come down, come down, come down. Check our alignment, right? Because we should be able to get it clear on all sides at some point. There we go. So now we're clearing all sides. So we want to be just a little bit, whoops, undo. Want to be just a little bit, oh, we're not quite there. Are we there? Can ungroup all this and match that like this and come over. Yeah, see? So we must be an odd size. Yeah, we got to be 3. So now we're now the same diameter. We're now aligned to the hole, right? But we want a little bit of bite. So maybe we'll be 2.8. Now, I haven't tuned my machine, so my circle holes are not always the best. But we want to make sure we're sort of in line with that. And it's hard to tell because it's not 3D, right? I don't really like that, but oh, that's too much. We want to move over 0.05. No, it won't let us do that. 5, and then we want to. Right? No, that's not right. So then we want to move over. Getting into the preciseness. Okay, so we're going to cheat a little bit. We're going to make this centered. We could actually be 0.25. I don't know. What's 75% engagement? Let's do 80. No. What's 80% of 0.3? Calculator it again. 3 times. Okay, so 3 times by point. That's not right. Divided by 0.8. Clear. Hello there. How are you, sir? We're just doing some Tinkercads today. Tinkercads. Okay, I forget how to do division. By give me. There we go. See, I just hit the wrong buttons. 2.4. So we probably want this cylinder to be 2.5. I think that's going to be way too much engagement. Oops. No, wrong button. 2.5. There we go. That looks pretty center to me. You could split the difference. Can we? it's gonna be 0.5, right? So nope, we want that to be 0.05. So move it over. There's center, right? That's how you do center without actually doing center, right? So then this and this are, I guess this we can make the after. Have a 0.5 edge. That's a bevel, but it's not quite right. And the reason why, did I do 0.5? It's not going to be quite right. Now, this needs to come up. I want to almost kiss the face like that. A little gap in there, a little bit of breath, a little bit of air. But that's what we want, right? So, and then this here, this block here, which is color, of course, this can come up because it dissolves into this block, right? There's our mount, but we can actually make the base of that mount bigger. There's a couple of ways. We can put feet on it. Do you guys want to put feet on it, or do you want to put, do you just want to make it flat? I kind of am tempted just to make it flat, but it'll take more print time. So this here, so we don't have screw holes over here. So really we can ignore this because we have screw holes here. So we'll do the same thing again. This, copy it, make it super tall, take it over here. Rough center. Not quite right. Can we move that? Right, so there you go, like that, right? And then that whole, it's good to see it all the way through, so we'll see it all the way through. This now needs to be reduced in size, even though we don't actually need wider as well. That parallel, I guess? Oh, that is parallel. Okay, so we can actually come up. I think this whole thing needs to be wider, to be honest with you. Anyway, so then we go back to our screw hole. We're going to just zoom in on it, check its orientation. Its orientation looks good, so we're going to copy that. Come here to this edge, right? No, we're not going to do that. We're just going to manually move it over. It has the same problem where it needs to be moved just a hair over. This needs to be 5, and this needs to be 0. That should give us our through holes, right? There's our through holes. So maybe we'll just make through holes all the way through and just be lazy about it. There's our through hole all the way through. And then the screw will self-tap, right? Because it's only PLA. So there's our render. I think this base needs to be bigger. What do you guys think? It just needs to be bigger, right? Because the problem is that when we put it down, we want it to not roll over. We want it not to have any issues, right? We don't want to put any clips or anything on the USB cable because we just want to plug it in, right? So let's agree with that. We can actually put retaining walls on it as a cheat, so we don't necessarily have to use screws. So what we want to do is we're going to take a block, and we're just put it on the wall there, and then we're going to move it out 5, right? And then we can bring this in like that. How thick does that end up being? And then we just come this way, like, we undo all that because we screwed that up. We'll take this back like that, right? So it doesn't have to enclose the whole motor, right? It's not the end of the world. And then we're just going to take this, we're going to copy this, and we're going to magnet it. We'll take this magnet over to this side. So sometimes you have to magnet it to somewhere else, but there you go, like that, right? And then what we'll do, move this over. 1, 2, 3, 4, 5. Because the afternoon, Vince, how are you? Because, like I say, the filament is not, unless you've got it really dialed in or you're using a smaller nozzle, which we won't be using. We'll be doing with number 4. Remember, I like to do everything with number 4 because that's what you guys have. I do have number 2s on both machines. I even have number 2 for the big machine, which I have to remember to keep, I got to do something about. So then this and this blue guy align to this. And this might be just too small. This might end up being really small. It doesn't look really small to me, but again, it could be. So we're going to leave these sharp, although we're going to square these up. Right, and we're going to make sure they're the same height. Right, so we're the same height. We got a little pocket to put the motor in. It's got a little base. You know, it won't run away from us. So I think we take this and we lock this, and then we take all of this and we group it. And I think we run this. What do you guys think? Do we run this? It wouldn't. It should be like maybe 25 minutes. And of course, we try to keep the colors different, right? Run it? Yeah, we can run it. I'm just waiting for it to load. Do it. Do it. I know. Here on, like, we may have to just end the YouTube because I miss all the buttons. And since YouTube, it's not really, you know, like, I gotta double check what's going on here. But, yeah, it's, you know, it's not that popular, you know? I don't know how many people are here, but only 2 upvotes or only 2 likes. Here's my third, just to be vain. Um, it's you never really know, right? So, do I add timestamps? Sure, add timestamps. Why not? Yeah. And it's not like Twitch where it shows me who's in lobby and who's not. And I like knowing who's in lobby. Trust you me, I'm kind of a nosy guy. Now, what we can do is we can look at this. We'll take that out. And that is a really interesting hole. There's really, really not the best. But we'll see, because I don't know how well it's going to print, right? But we have boxed it in, so that's not, right? Because we can always make a strap that goes across the top of the motor right here. Like, if we don't like it, we'll just remake it. But I think what we're going to do is we're going to export this. So this is a 90-degree motor. Unlock this stuff because we're going to put this on the build plate, right? So now we know it's on the build plate. So I still think it's awfully small, but I could be wrong. It looks small to me, but I guess it doesn't matter. Yeah, yeah. Have a great day. Thank you for being here. Drop in later. I'm on for at least 4 hours today. I had a rough morning, so I might be on a little longer than that. Now, we could support the motor. Should we support the motor? Could support the motor. I don't think we need to support the motor. Really see my offset. I guess my offset, we'll just use the model as the offset because that'll give us the information. So we do the same here. We come along and we just find the bottom of the motor, right? And then we come down just a little bit like that. I almost feel like we should do the clamps. Because it doesn't matter. This can matter. Like, I feel like we should do the clamps. These can be wider. Or 5 mil? Yeah, but if you put in a 3 mil screw, 7. Yes. Oh, it's gonna sit nice, but I'd rather do a clamp maybe. Up flat maybe. Then we just make a bar that we like fitting between the two. Now remember that height in there is only 1 mil, so it will, if we do put a bar, we're gonna have to adjust where our wheel sits. But if we make that 2.5, 2.5 mil, that's pretty decent thickness, right? The wheel will have to float above it, but it's not the biggest deal, right? I don't think that's a big deal. And what we could do, make these taller and just make an indent for that. Parallel to the same height. And we just copy this. Everything needs to be stop being so red. Anyway, we'll copy this. We'll make this a hole, but we're then gonna make it 7. No, we're not worried about length. We're just worried about width. So no, that's length. So width, we'd probably make it 7 mil. 7. And then we want to, so we'll lock this. Can we just select these? I don't think we can. That's okay if it's a little bit out of. There's our slot, and then we just make our slot a little bit bigger, right? So that the rod sits in there, and then we can add. So we just, can we select those two? No. Color, because it's driving me crazy. These two can align. So those two are aligned, right? So now when we punch a hole in something, we can put a 3 mil in there, right? And then we have enough room for the cap size. So we will then group these two, this, which then punches the hole in it. Now what we need to do is make a 3 mil screw hole. So we need a 3 mil that goes into the housing, but we need a 4 mil so there's clearance on the top of the screw. So these ends up being 3. Boop. And then this here needs to be 3. Boop. Right? And then do this again? Yeah, we undo it. So we take this, copy it, and then we bring it back over here till it clears this. This cuts a hole in that. Perfect. And then this comes over here and cuts a hole on that. Perfect. Something like that. Yeah, something like that. And then this needs to be centered to this. And now you understand why I had to go back and do that extra step. There we go. So we're centered, right? And then we want to take this and center it to this. And you'll see here in a second why. But we're going to align. We want to select that, be center, right? So now we're center, right? Okay, so this bad boy goes down into this. But then we copy one, and it comes up, and it ends up being 4 mil, because we want clearance on either side of the screw. And then we shrink this one down until we can see the other one. See how we can see the second scroll there? Select this bad boy, this bad boy, and we have that one. So it goes up, up, and if the circle doesn't move, well, that's you know that's a problem, right? So then we take these two and we group them, and they won't disappear because they haven't been added to a solid object yet. They won't disappear. So we can then take those, move them over, align center, and then ungroup them, then drill our holes. So we then copy this, we come over here, and we find this, and we align center to this. Nope, undo. Like that, you see? And then we just want to make sure that there. Okay, so we now take these and we ungroup. So we take this little guy and group him to the big guy, then put this guy and this guy. Now this doesn't need to be so tall. Right? It has to just go through this. So we just double check our sizes. Yeah, we're 4 mil, we group to that. Now we could leave that because we come here, we ungroup this. We take the little guy, we group to this, right? Now these two can be paired. And we might make sure, and then we make sure there's center on here, right? They are, okay. So these guys can all be grouped. And now you have the hole through, right? Because the cap is going to be bigger diameter than the hole, no matter what you do. Unless you're using a grub screw, which is like just a thread, and inside the thread, the core of the thread is a hex key, atypically. They're not known as Allen keys because Allen key is a brand. Now what we can also do, we'll leave it, but what we could do is we could actually trim the corners off this so it's not so sharp. But we'll leave it for now because we're just testing, right? We're just playing with the thing. So now we're going to lock this. Then we're going to group all of these, right? And no, we're not going to do that. We're going to ungroup these. We're going to lock this. Sorry. Then we're going to group this is all the base now. And now all the base should come out. So when we select the base, it should all come out as brown. That's everything we need. So if we're worried about tilt and spin and whatever, if we're really worried about this center rod, we can use the holes. We can choose what we do, right? If we're worried about these pillars being too tall, we can trim them back in the future. But, because we can make this an L, like an L shape. And then once we have a base mount for it, that should get us started. So while we're printing that, we'll then start to print components. Because we still have to figure out how it all goes together to make the paint shaker, or, I'll just show a turning cylinder. But anyway, so this will be the mount. So export that, right? STL. Wait for the export. And then what I'll do is this is the crossbar. Unlock. And then I can export it. Export. And what you can do, I'll show you a thing in Tinkercad. Because there's this funny thing in Tinkercad that I don't think a lot of people know. I'm just going to wait for this. Once this is done exporting, I can show you. And then how long are we on time now? Oh, it's break time. It's break time. So I'll be back soon. I'm going to put you guys... I really want to load this, though. No, I should take my break. Because who knows how long. So, give me... You know what? I don't even care. Let's do the Bambu slicer, because it's better to be watching the machine doing something than just sitting there, you know what I'm saying? I do really like those new tanks. I don't know. You guys know anything missing on them? You got any feeling about what's missing on them? I guess you need a release to actually have an opinion, don't you? Maybe we'll have to release them today. I do have some really good clam shots. They were all made on the J1S by Snapmaker. They came out nice. Public minor releases, I don't need that. So let's prepare. So can you see what I'm doing? You can see what. Oh, look at that! We got both parts done. Okay, see, that's my patience. No, I want to arrange. They look okay. They look okay. It doesn't look great. It doesn't look bad. It's kind of just basic, right? So we'll slice that. Let me get the G code. So yeah, these little tanks, they came out nice. I think they're really cool. They got multiple turrets, and on the heavy tank destroyer version, so the big version, they have like multiple hull mounts. And I haven't decided, but I might make sponsons on it. I don't know. You guys are like, That's like a World War I, World War II thing, because they used to use those to clear trenches. That was the idea, and then they started just putting huge cannons on them. But that's kind of like, I don't know, that's like a feedback thing. Do we want sponsons on it? Yeah, do we want sponsons? I'm not sure. Crossbar G code mount. I guess. I remember it adding G code though. Oh, I need to figure out. Does anybody know how to change the music on your 3D printers? I know. Was it TechJeeper did it? I need the G codes. What I want is something where I can import music into a generator and have it generate the G code for me. But I'm not even sure how to explain that correctly. Does that make sense? So this is and then we'll do it like might as well do it in orange, right? We like orange around here. So that'll mount into orange. So that'll be the first mount for the drive, right? And then we can go more complicated after that. But once we can mount the drive, that's what matters. And then I think we're doing a wheel. Like we could do a gear, but I just don't know about gear interlacing. That's like a whole different animal. We could do a wheel, and if we know the width of a rubber band. Now I don't think I have any rubber bands, but we could think about it. And we can make this interlock into something else, right? Like it's not. We just use this for testing, and then we move on to the bigger shapes. Does that make sense? But we can also just do a wheel with a hole in it and a rod that goes into a plate that moves in and out. I just don't know what the length of that rod has to be. Anyway, I'm gonna put you guys on break. The machine's booting up. You can see it here right now. I think you can see it is booting up. We're gonna be running it in Polymax PLA. So it's Polymax PLA. It's my favorite. Orange, or it might be Snapmaker Orange. It may be one or the other. I'm not sure. I just can't see from here. It looks like a Polymaker reel, but it could be a Snapmaker reel. Anyway, so I'm going to take my break. I'll be back soon. I love you all very much. Good morning, good afternoon, and good evening. Welcome to the Heathen Workshop. My name, of course, is Maker Millwright. Maker Millwright, you know, millwrights. Anyway, so what we are doing is we're just playing around with some Bambu parts. You can get these parts from the Bambu shop. I got them through my points, so go download my. I'm gonna put my link in for my thing because none of my links seem to work when I try to do them through Tinkercad. So this is me. This seems to be very popular right now. I'm very happy with that. I'm glad you guys are boosting it. I'm glad you're doing so much for it. This is the truck I designed. I actually have none right now because I gave them all to my local food bank. It's just a really popular toy I've designed. I hope you enjoy it. It's a print and place model, which means, for those of you that you can just print the model and the wheels turn. They're separate, but internally part of the model. So what you can do is you can print the model and just roll it. I have an example of a different model I'll show you. So I use the same frame design, right? We're working on different versions of it, upgrading and stuff, but I like to show my progress, if that makes any sense. So this is the next one. I like to show people where I started and where I'm at now, and you might say, well, why? Well, because I think everyone should be able to design in Tinkercad, right? I think you should be able to make what you want. Now, yes, there are excellent designers, and you can totally 100%, um, you can totally 100% like what's the word? You can totally like 100% make your own. You can totally 100% use someone else's, right? If designing isn't for you. But these are, I'm just going to put them in the write-up, and I'll show you that one in a second. I'm just because I didn't put the link in the right spot. So these are, so there's really good designers. The ones that stand out are Jayton 3D and Fix'em Dude Motors. You can do that is you can use their models as well, or mine. It's up to you, totally up to you. Um, or you can make your own. And I did on one of the streams. You have to go back. I'll have to go back, maybe label it better. But on one of the other streams, I showed you how to make your own. Right? So you can make your own. It's totally up to you. The print and place practice is actually a lot easier than you think. Unfortunately, I printed them in silk and forgot to increase the walls and infill, and my kids broke them, and the wheels fall off. Sean, I don't know if there's anything I can do on my end to fix that. Yeah, silk is a little bit more on the delicate side. Um, I don't actually recommend silk most of the time. It's like a finishing project, right? But if they liked them, print more. And womp womp, yeah, it sucks that it broke. Or they were big enough, nobody choked on them, nobody chewed on them, nothing dangerous, right? I hope. But yes, Sean has a valid point. When you are printing these, if you are going to in softer materials, and there are softer materials, I would recommend more walls if you're using TPU or silk. Um, and I generally increase the walls anyway. That's just me. You should be able to get away from the breaking part by increasing the infill, but I would say put the walls. I have thought about putting a cylinder hole. Everybody safe? That's all that matters to me, right? I don't want anybody to get hurt by the stuff I make. That's makes my heart happy. Did you enjoy the models while you had them though? I'm gonna grab the one off the wall here. This one's made out of Polymaker. It's a bunch of different Polymakers actually. So it's a Polymaker Polylite. So the new, because they changed the name, right? They changed the name to Panchroma. So it's Polymaker Panchroma Black. That's what that is. The first half is Polymaker Glow in the Dark. I don't know which color. I've yet to try it with the black light. We could do that now. And then the other half is in Nicor Rainbow, which is a glow in the dark. It's weird because it's the temperatures were the same, but we got a little bit of drooping on one side, which is weird. So let me get the light. And we'll play with this a little bit. Oh, they loved them. Perfect, perfect. That's what I want to hear. I know, egocentric. I get it, but when you're making stuff for people like I do, you want to hear they liked them, right? Like you want to know that it did good. And remember, like this is probably more of a kid's toy than I usually make. The battery in these are super dead. Oh, I don't know if it's gonna glow. My batteries are super dead. But it's glow-in-the-dark blue. I just found out because I can tell by the glow percentage, which you may not be able to see, but if I put it in the daylight, maybe. But it's really warm, so it got warping Gorperson. See that blue? You can look at the blue. So I need actually more powerful glow-in-the-dark lights. These are good, but they're just not strong enough. So maybe put them on the throne or something. If you guys don't know, I have a throne. Uh, I don't know really what to do there, but yeah, it's glow in the dark blue. I like glow in the dark. Glow in the dark's fun. Glow in the dark is hard on your machine though. It works fine in the dual extruder and the IDEX because it doesn't have to do as many swaps. But with the AMS Lite version 1, I'm waiting for the AMS. So we got 30 minutes before our mount is done. But with the AMS Lite, you run into the problem of the retraction isn't strong enough to pull the wire back. Does that make sense? So it gets caught up, in my experience on the Bambu, it gets caught up on the cutting blade, and when it tries to pull it back, because the diameter is rough, the glow in the dark is rough. When it tries to pull it back, gets caught in the head on some of the more delicate parts, and then the AMS Lite won't rip your machine apart. It just won't. It just says fail. So that one particularly, and a bunch of them were run on the J1 from Snapmaker, just because I love Snapmaker. I try to promote them where I can, right? It's just a nice alternative to Bambu if you're into it. And the J1, now the J1S, because all of them come with the auxiliary fan, but the J1 is IDEX, so it has two different heads. I should put it here on the channel, but the Bambu, it just does such a good job. I've talked to Snapmakers, seen what they can do for me. We'll see what happens in the future, right? But again, like the new U1, I'd like to see how the U1 handles both TPU, glow-in-the-darks, dissolvable filament, breakaway filament, and higher temp materials like ABS and ASA, and nylon. And I want it to switch and whatnot. I want it to do a bunch of weird things, because when you have four possibilities for nozzles, it has the opportunity, right? But like I say, if I make something and you guys enjoy it, please let me know, because I love hearing that. It does build my confidence to make more of those models, if that makes sense. So yeah, I added those two to the list for today's show, and I reposted it on the Discord. So if you haven't joined the Discord, yeah, we're definitely more active on Twitch than we are here on improve your experience, follow updates. Oh, I was just talking about the new updates for the H2S, which I am interested in. Like I said, I'm big into anything, right? Any kind of technology. I'm the guy who's like, yeah, send it to me. I'll make stuff out of it. I have been having a few issues with the Artisan. I have to remember to send out an email. I always forget to send out an email. But we can go back and we can look at. So now let's put a wheel on it. So we have a motor with a wheel and a mount. So we have a start of something. So let's take a look at that. So I'm not sure how best to do this. We could do. We're happy with all this, right? We're happy with all this, so it all gets locked. That all gets locked. That's now our working procedures. Right, we'll see how well this does when it prints off. It should be done soon, about a half hour. You guys hang tight. Now, remember, this shaft turns at 60 RPM. Now, I can go look up the math for feet per second, but as we get bigger on this wheel, we actually end up going faster because there's more surface area turning. Does that make sense? So even if this is, hey, Jayden, I just was talking about you. Were your ears burning or were you sneezing? So what we want to do is we've got a couple choices here. We can make. How do we want to, let's just play with the wheel first and then go from that. So we're gonna go from a diameter. What we did diameter this was 7, and then we can go. So we probably want to magnet this. So magnet function allows you to change the work plane. And now we're floating, right? But what we probably want to do is we want to probably unlock this, unlock all of this. Oops, sorry. Want to ungroup all of this. Now remember, this is all locked, so we're not worried about messing with it, right? We're going to ungroup it. But what we're going to do is we're going to ungroup this, and we're going to try and find that little hole there. Yeah, perfect. We're going to copy one. We're going to put it back in place, so we're through that, right? And then what we'll do is oops, undo that. Is we're going to take this, and this is now our center. That's the dead center of the turning shaft, okay? So now we're going to take that, and we're going to lock everything. But we're going to lock this one first, and then we're going to take all of this. Now you can see how it selects everything, but the purple says it's locked, which means you cannot affect it. We're then going to group it. That'll group all the motor assembly again, right? And then we just take this and we make it gray again, right? Gray, because I work in gray all the time. Now this can be any color it wants, right? So cylinder, gray, black, probably yellow, right? Now that's our alignment. Now what we could do is we could shorten this, so we could go here and we could take this, go down to the bottom of it, right? And just shorten it all the way up. And then we can take this and we can come down, and you can see down there, the hole doesn't go through the housing. So we can take the magnet and we can go inside the hole. So nope, we're not inside the hole. Hold on. Now we're inside the hole. But see, that screws up all of our alignment stuff, right? So what we do is take that and we go, okay, well that's our thing, right? So what we're gonna do is we're gonna come in here and we're gonna make this a hole so we can see inside it, right? And we're actually gonna make everything a hole so we can see inside it. Now we can take this, we'll just zoom in here, we're gonna take this and we're gonna look at that. That's what we're looking at, right? So we want to take this and we want to take that and we want to come up till there. I don't know why we're in the ones position. I don't have any idea what's going on here. But we're basically going to take this pin, and we're going to come down to the seat right there, right? We can have a little bit more, maybe a little bit more, right? There. So now we know we're sitting at the bottom of the shaft. So no matter what happens, if we go to the bottom of this pin, which we're now going to lock, we're going to sit on the bottom of the shaft. But we don't really want to sit on the bottom of the shaft. We want to sit on the housing, right? So we have a couple choices here. But because we have this bar, which we don't necessarily need, but that bar shows us our clearance to the objects, we can just say, okay, well that's, whatever, right? So we can take this and we can align center to this yellow pin. Right? Now we're aligned to that center. But you can see we're rubbing there. We don't want to rub there. So what we can do is go back a step, take a block, sit on here, and we're just going to come down till it clears. That's now clearing. So we now know that clears. And we can have a square block in here. We can have a round thing. It doesn't matter because we're sitting on that, right? So we just want to make sure we're clear of everything. So there's, whatever, right? And what we do is we probably put a cylinder in there or something. I'm not sure yet. But what we want to do is no matter what we do here is we want to be clear of that cylinder. Okay? Or sorry, clear of that. So maybe we do a round. So let's take a round. And we're going to sit here. Then we're going to align center to this. Right? Scale this down until we're clear. And now we're clear, right? So that, bare minimum, that has to be the throat, right? And we can mill it, and we can do a bunch of stuff to cut the hole out of it, because like basically what we would do is we then take, actually, you know what, I'll show you what we're doing first. We're going to make it round, and then we're going to come down until we clear the shaft, like that, okay? So you can see we can mount screws to it, we can put flats on it, we can do a bunch of stuff. So what we can do is I think maybe we'd do, yeah, we're going to do flats, so it only fits one way? Sure. Not really sure what I'm doing here, so just hang tight with me. And then because we want our flats to be the same height, we'll come there, maybe just a little bit above, right? Then we'll copy, we'll magnet, right? And we're going to magnet to this side. And then we're going to make them parallel. We make the heights parallel and centered, right? So we got to center the two, right? And then what we're going to do is we're going to raise them up. So we'll group them. And we're going to raise them up until we have just a little bit of clearance on that wheel. Like that. Right? Just like that. And then we have to double check this one. We're too deep, so we need to come up just... See, we're too much right there, right? Right? So, and then these, we can ungroup these, and these can mount... Oh, what do I want to do here? I forget what I'm doing here. I think I need to take this, and I need to make another one, and I need to make it bigger. What am I doing? So these need to be solid, so these can come in until they're like that. I can take this one out of here because I made one that fits I like the look of, right? So I copy this one, and I magnetize it, right? Because the magnet just brings it to the plane. And then we can take this one, and we can align. Now we're aligned, but what am I thinking here? I think these end up being... This needs to align as well to this. No, this needs to align to the center pin. And it says it's the center pin. So these need to be solid. No, they don't. What do they need to do? This needs to come up to this. These are my negative. This is now negative space. So that's my cutout. Is that right? I think that's right. No, it's not. Is it? Doing something wrong here. So this ends up, so this ring needs to be a little bit bigger, so we're going to make that ring just big enough to fit like that. So then this center ring cuts this out, and then that's too much clearance. No, that's an okay amount of clearance. So that and that, this and this group, that cuts out our shank diameter, right? So it gives us enough room to push down. And then we need to make those solid. But we got to move these out. I think that's what we're doing. And then for the rubber band, not sure how we're going to do the rubber band. And I don't want to screw together a wheel. I want a wheel you can just print. Do I make this have a core? And then the core sits inside the wheel? And you end up with a two-piece wheel. So then this, so these need to move just a little bit. Because see how they're touching? They don't need to be touching. So they come out 1, 2, 3, 5. That's too much. So right there. And then these become solid, I think. Yeah, I'm pretty sure these become... So what do we say? 3? And then this becomes like this. And then this becomes like this. And then this comes up to the height of those. And these become solid again. I think this is what I'm doing. Now, we do have clearance for the wheel. But my question, I guess, is how do we print that? And we put screw holes in this. How small screws do we have? Let's look here. So again, I'm going back to the box, right? So let me look through the screws. So I'm going to pull out all the screws. These are cool. These screws. Oh, what is that? I don't. And remember, we have a speed controller for this, so we're not too worried. So these are all my screws, washers, and everything in between. Um, oh, we go really small. We have really small. Okay, so and then we have a couple bearings, ball bearings, springs, things like that. What's this? That's another washer, some springs. These are. I want to keep all of the, because that's a surge bearing. It's like two separate halves. Um, what's the name of it? Forget the direction. Direction. You put it on things where you're pushing out. Okay, so we got springs, dowel pins. We don't need those yet. Got what are these? These are bushings. Deep ball groove ball bearings. Sure. Springs. Springs. Screws. So the M2s. Oh, M2s. The bane of my very existence. Self-tapping. 2.6 by 8. It's interesting. We might use that. Some more shanks. These are what these are. They call them dowel pins, but you use them as axles. That's what I would use them for. What are these? These are M2 by 8. Again, M2 is the bane. M3s. These are deep M3s. We might need those to assemble things. I'm not sure. Got some Big Daddy M5s. We don't need them just yet. We got some nuts, 2.5 nuts, but we don't need those yet. We got some M2.5 instead of M2, which is slightly bigger, easier for me to handle. We got a bearing here. What kind of bearing do we have? Deep groove ball bearing, 6704. Self-tapping 2 mils. Those aren't terrible for this project. We've got some flat stainless steel washers, but those can act as bushings if you need them to. We got some MR52 deep groove ball bearings. I'd have to look up the diameter of those. Curious what those are. We got some balls, so we can make our own. Got some 6 mil ball bearings, so we can make our own bearings. We got some brass dowels. 2 by 33, 2 by 13, and 2 by 22, which is good because we can use those for our axles. 2 by 6. The 2 by 6 is probably what we want for there. I don't know. It seems a little short, but got some more springs. Tension springs, although we'd end up probably breaking those if for the design. Got some longer 2 by 14s, 2.5 by 10. Call them machine screws, but they're actually hex cap. Yeah, hex. These are countersunk, but they call them counter. I don't know what's going on. So let's so we kind of know where we're at. So M2s, that means there's a 2 point, should be a 2.95 to 2.01 diameter shank on the screw. It would be nice if we had some of those longer self-tappers, but we can use them. Okay, so what are we looking at here? M2 by 8. That's probably too long. M2.5 by 6. What's the diameter of this? This is probably too thin. 6.9, so that's okay. As long as we countersink them. M2 by 10. That might be what we use. And just have the cap out. M2 by 8. That might be better because I don't know if we want to use the 6. I want to use the 2.5. M2.6 by 8. What is that? Oh, because these are threaded. Self-tapping. We might be able to just fit this on and we might have to do screws later. I don't know. We're going to keep these ones in mind, I guess. So we do have a lot of M2s. So M2s are kind of a good thing. Kind of a good thing, you know what I mean? So I still have the motor out for no reason. But okay, so the outer diameter of this is 7 mil. Which is fine. So I think that we take our flats, We taper them. May not, maybe not taper them right now, and then we'll make them whatever later. So then we can sit our wheel on top of this. See our clearance? So we can now take our wheel. 20 mil is really big though. Should we go down to 10? Because that, what's the ratio? What's the difference between? We need to look at this because I don't know. I don't remember the diameter of the shaft. So we're going to copy this, lock it, right? Because that's our main model. That's the one we're worried about. So we'll ungroup this. How big is this? This is 5 mil. So it's a 2-to-1 ratio if we go to 10. So it doubles our speed. Now we do have a speed controller and we can turn it real down low. I don't know. Oh, I don't know, Davey. So if we go 10 mil, but 10 mil is a decent size. Let's go 10 mil. Let's just do 10 mil and see how it goes, right? Like 10 mil. And we probably want it 5 mil deep. Now the question is, how do we put a curved seat into it? So I can take a torus. Can I determine the inner tube diameter? No. I change the height. If I do 2 cones, so take a cone, and how tall is this? Is it how tall? 5 mil. So if I go 6 mil, because the width doesn't matter, just the diameter. So if I want the, oh, and then no, because I just have to, there's nothing because it can be flat. So I'm not worried about any of that. And I don't want to screw into this because I only have one of them. So if we're going to slip it on and screw it down, we have to screw it down on the housing. Okay, so so my inner diameter, my outer diameter is 5, right? No, my outer diameter is 10, but it has a radius of 5. So if I turn this to a radius of 5, and my top radius of 3, and then I make it 2.5 mil tall, 2.5. Do it? Turn my sides up. I need it to be round, but 2.5, 2.5. What? And then I make another one, flip it, and that should make my wheel. So I need this. So how tall is this? This is 2.5. So I need this D. I need this to come up 2.5. And that'll give me my crown internally. And then I need my sides to be 120, and I have sides of 20. But does my crown need to be that deep? Can I do 3.5? Yeah, that looks better, right? And then if I'm worried about it, I know my inner diameter is 3.5, so I can take this and I can do this, and I can do like 3 point, so turn all my sides, and then I can do this 3.5, and it'll give me a flat in the center of that crown. And then I have total height here. My total height should be 5. It is. And then I can align the 3 of them. Center on. It doesn't. Okay, so my crown. I want this to be 4 then. because then it'll take the bottom of the crown out. Because it's going to be really steep if it's internally like that. So then I take this and like this. Undo. Okay, so that's weird. Oh, because it's radius. So the radius of this is 5, so it ends up being 10, and I'm doing diameter. So I need to go back. So a radius doubled is the diameter. So 3.5 is 7. So this needs to be 8. I don't know why Tinkercad splits the two, but I guess it has something to do with the math. So if this ends up being 8, and then I put the two together, and now I see how I have a flat so that it's crowned on the edges, but it's flat in the middle. You kind of want that because yes, you you could have it like crowned to either side and have it crowned all the way down, but then it probably won't seat because you'd have to figure out the distance. So that groups, and then this goes here, and this top of then this and this align like this, and now we have a shiv on the end of a shaft. And then what we can do is we can crown the shaft, because this will print vertically. So then we take a cone, and we want to take this. This becomes one color, sure. And then this becomes transparent, and then this becomes solid. And then we come up until we come into the center of this. Because then we can add a taper to everything. And then basically what we can do, yeah, see how it's starting to already cut that edge back? So what we want to do is go in. We're doing this the hard way. Let me just do this the easy way. So we're going to take this and this, and we're going to copy these, move them over here. Then we're going to do the crown again, and then, oh, look, it finished. We got to do our wheel now. And what we can also do is we can make those wheels flatter if we want. We don't need this Torx crown. This is how I should have done my maker chip. Now that I'm thinking about it. I did it totally wrong, but it's okay. It's okay. You guys don't mind, do you? And you might say, well, why do you want to make it a hole? The hole is so you can see where the cone comes up into. And now it puts a taper on everything because the cone comes in and cuts everything back. Now, could we determine that ourselves? Probably. Am I too lazy to determine that by myself? Yes. So now we just got to make sure it's aligned center. And it is. So this becomes a solid again. This becomes a hole. This groups with this. And then this cap. This is a hole. So it is touching. So this can be a solid. I'm just making sure everything's solid, right? This should not be multicolor, although it doesn't really matter. And I'm sure, did I double check this? I'm going to double check this. Ungroup. So this gets locked. Then we take these here and we just make sure they're center on center. Nope. These here, center on center. They are center on center by the looks of it. Yeah, they are center on center. Okay, so then we unlock this. Just double check your work. It only takes another second, right? Okay, so that is now our wheel. And if we don't like that wheel, hold on. So we ungroup this. This gets grouped. Then we make a cylinder. What we're going to do is we're just going to shave off that sharp edge. Bring the height down. We know it's going to be what, 10, is this 10 mil tall? 5 mil tall? So if we make this 5 mil tall, boop, bring this up. I probably screwed this up, but it's okay. Just make this parallel. The bottom, and then we take this and we're going to go, oops, undo. Find that center, and then we're just going to kind of shrink it down. Just till we get to that edge, because we actually want it to be a little bit smaller, and I'll show you here in a second why. Like that. See how it's starting to take that rim away? Like that. Okay. That's what you want, kind of. And the reason why, I'll show you now. So what you're going to do is just make sure this is still aligned, center on center. It is. Okay. You're going to take a cube, and you're going to make, well, how tall is this? This is 7. It doesn't need to be 7. It can be 6. And then we go down just so it's just a little bit past. We're going to take this cube. We're going to also make it 6. And then we're going to align center on center with this. I never knew Tinkercad made noises, just so you guys know. And then we're going to group the two. And then what we're going to do is we're going to turn this into a hole and trim back our wheel. Now our wheel is got, instead of it going all the way out to a cone, it's now flat, which is, you guys have probably all seen that. So now that this is we now unlock everything, group it, and then we turn it one color so we know it's done. We're going to align it to the center of this pin. Actually, what we're going to do is we're going to align to the bottom of this clear cylinder first. We are aligned to the bottom of it. So we can delete these out. We don't need these anymore. This now will align center on this pin. And there's our shiv, right? Or a pulley, depending on what you know. That's known as a shiv. And then what we can do for the second component of this, we're going to just copy this shiv out. And we just keep the ratio. Because I don't think we can stretch it. Can we stretch it? Go bigger. So if we go 5 to 10, that should be a double ratio, right? This needs to go 10. And we bring it back down to 5. And that's now a 2 to 1 ratio. But you can see how our arcs got all screwed up. So we'd have to do the same math again. So did we write that down? Oh, I guess we didn't write it down, but let's do this piece first. Okay, now here's that trick I was telling you guys about. In Tinkercad, in the title, if you put a slash in, /, it will just label whatever the part is. So if you're working on a main file, what you can do is then go put that slash in, right? So this is the 90-degree motor mount, right? And then we'll do shiv. And then we'll have to figure this one out. But this will now, we can now take this and export this and put this on. And then see if it fits. It might be too tight. We might have to file it. We might have to fiddle with it. I'm not sure. But now we have that. The other thing we can do is make a wheel that fits on this. So we take this, we copy it, and then we just make a wheel. We can crown the wheel though. Take this, and we just want, what diameter is this? How did it end up smaller? Oh, because we shaved it. So we'll do a same thing. We'll take a wheel, and we'll make it 10, just because that 9.75 is the outer diameter, not the inner diameter. The inner diameter is 8. And then we make this 5. And I think that's really small, but that's okay. And we come up here, and then we come over here, come up, So we want this round because this is we're gonna see. It'll be hard to put a pin in this, but we can try. So we're gonna make it round just so it turns nicely, and then we come up that and just make sure. The only way the way we check is we make one clear, make the other not clear. Does that make sense? These end up circuit like that and like that. Because if we want to put a hole in this, which I'll show you in a minute, let's do this thing first. So we're gonna go on here. We're going to, can you see this? You can see. Okay, so we're gonna go new file. We're not saving any of this. We're going to add something. We're gonna do the shiv. And then we're going to just see what auto rotate says. That's what I figured it would say. So there's our flats, right? And they're tapered so that that fits down over the shaft and then self-aligns. Okay, so can we print? So we're going to go to a finer layer height though. We're going to go to, let's try high quality number 12. We're going to go, we're just going to leave it. I don't know why it's got me spec'd out to all the basic Bambu stuff because it's not basic Bambu. So 16 minutes, you can see that we got our layers. Now, this is good and bad. You can see the layers are going to be in the direction of the shear force. And the only other way to do that is to split that wheel and stick it together with screws or glue. That way we can change the shear plane to a singular nonlinear, to a singular plane as to opposed to the whole plane that in which the object is on. So let me just grab the thingamabobby and we can test our design. We may have to make it bigger, we may have to make it smaller, I'm not really sure. That took 43 minutes. I'm so surprised. And actually we're using Snapmaker Orange today. Good, there must be glue on that build plate. Give me a second here, we'll bring it across. Our screw holes look good. We're looking pretty good. We'll see how it goes. Jayton, when are you going to explain to me how you built that tank? You did tell me you were going to build one. I didn't realize you were going to build one that shoots. Or maybe I do. There's something in my brain that says maybe I already knew that you were going to do that. This is our motor shiv. We don't need, so we now eject it. We can now shrink this down. You can go back to Tinkercad. But it's pretty easy because we kind of determined, oh, well, we want to be a little bit bigger than the shiv, right? For the core. So we just keep the ratio, what was it, 3.5 to 1? Or 3.5 to 5? I think that's what it was. Here, so this is now, we'll put our shiv on. Make it orange as well. I probably should have made it blue. So we know right off the bat, good sign. Right off the bat, our cross member fits. Right off the bat. So now we take our motor, right, and we stick our motor inside, and we look for our alignment using our crossbar. Crossbar should fit between the two, and it does. But it does put us back a little bit. That's weird. My pin must be in the wrong position. Tank just has the same mechanism as the flintlock. I know, I saw how it, but when are you going to tell me all about the excitement about it? Okay, so now this is wrong. So we need to lock this. We're going to have to change this. Okay, so we know this is wrong. And I can tell you it's wrong because the gap between the motor and stuff is thinner than the stud. So the stud is more forward because we can use that as our alignment, right? So we can take this and we can move this until it touches that edge, right? So we already know that this crossbar is in the wrong place. Is it a big deal? No. Touches because it's not there. So when I'm doing that, my crossbar doesn't fit. I can file my crossbar, I'm not worried about it. It does align, sort of, but the crossbar's too thick, right? So we already know that's a problem, so that's okay. So now what I need to do is, what I'm going to do is I'm going to file the crossbar until it fits, because I made a mistake. What's the? Oh, I guess you're doing the 1911 and the AK-47. Is that right? That the Barrett keeps coming up on my feed. I don't know if I told you that or not. Yeah, so that's doing really well. So I've just filed it back a little bit. Still doesn't fit. File the other side. But it does look like our screw holes are correct. Still doesn't. Oh, it fits now. Oh no, it's still a little too much. So I gotta come in here. What I could do is cut out a little bit of this, but I'm not going to. Because I could cut a hole in the center of the bar. That fits around the base there. But it's my fault because I didn't get the position of the gear shaft in the right position. Oh, that's close. I love it when you guys succeed. That makes me so happy. I'm also like really happy when you guys like, oh, I like what you've designed. I was like, oh, okay, cool. Close. What I do is I keep flipping the bar back and forth because I'm going to remeasure the bar size to change the gap, right? I know there's a Tinkercad measuring tool, I'm aware, but I typically don't use it because you should be able to use objects to orientate whatever you're doing. This is a little diamond file I got from the hobby store. I thought those were in the wrong position, but that's getting close. It really isn't that much of a difference, though, I'll be honest. Probably a quarter mil. Been designing too many to write the. Oh, wow, really? That's awesome. Because again, I prefer it when people make stuff to when people like work on all the paperwork for stuff. By the way, the base did come out nice. I am tempted to try the screws in it no matter what. The 2.8 mil might be big enough. I'm not sure. Although they're not long enough, right? So we got to use the longer 3 mil. But it does seat nice, I'll give you that. It's got a little bit of wiggle room, maybe a little too much wiggle room, I don't know. It does all of the clearances I wanted, although that, like I say, the pinholes are in the wrong spot. Back until I get to the edge of that gear motor. Still gotta keep going, that's okay. Getting closer. Quite a bit though, oddly enough. This is going to allow me to reposition the gear shaft. Because if on the drawing there, it's way farther than it needs to be. Getting there. Getting there. Then I just have to level out the tops because the burr is there. A burr is when material that you've removed builds up on the very, very edge. I gotta be careful because I don't want to change the profile. A little bit more. But like we're way out on the drawing. What I should have done is measured from the outer diameter of the gear shaft and then moved it relative to that. But I think I did. Can't remember. You guys are all gonna laugh when it turns out I don't actually need the crossbar to hold the motor down. Oh, we'll just cut it out. Yeah, but we're not worried about the cross member. We're worried about the alignment of the end of the gear shaft to the motor. The edge of the motor, I guess. Because might as well release the. Yeah, I guess keep filing. Don't give up. Be patient. It's almost break time too. I guess I should. Oh, it's almost done too. I wonder how the I wonder how um, rubber bands are determined. Oh, it did just finish. I can hear the motor resetting. Watch, I can totally measure that too. It's close though. Oh boy, boy, it does fit down between the two now, but it's not quite right. This is probably because I kept changing my datum lines. Datum lines is like a line you work from where everything measures back to that. And you will use that more when you're drawing something like this. Yeah, that's what I want right there. That's the size I want. So I just filed it down to get the right size. And we can change the design, right? We're going to take break here though. 5.8 between the two. 5.8. So that's easy enough to fix. Let me show you. And then we can just change the design, but we can actually reuse this base, so it's not a big. This needs to be, we need to ungroup this. This needs to go. This needs to go. 5.8. 5. And then what we do is we take this and we move this over until it touches. That's correct now. So this is this is what we got. Now you can see it very clearly doesn't align with the holes anymore, right? So we can move that over till we align with the holes and see where we're wrong, right? But we can change that. So what we're going to do is we're going to lock this. All of that. Leave that alone, and then we're going to lock it. And then the base is locked, yes. And this is locked, yes. So then all regroups. And then we can take this. And because we know where our alignment hole is, right? There's our alignment hole, so we want to make sure that lines up, and we know it does. So we know we're good right there. Okay, because we know it fits in the housing. So after I'm gonna put this on the display, but we can actually change some of this, put the hole back together and everything. But You know, we wanted the 5.8. No, 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 no. It's not. So, I'm gonna take a break. I will be back soon. I love you all very much. I'm gonna put this on the display, and then we'll continue our work. How's it sound? Good morning, good afternoon, and good evening. Welcome to the Free Heathen Workshop. My name, of course, is Maker Millwright. I hope you're all having a great day. So right now we're designing stuff around the Bambu motor assembly. And see, like we can screw it down. Let's try that first screw. So I probably need my hex keys. I don't know if I have anything that's small, but here we'll take the box, right? I'll see if well, let's see. We're going to use that self-threaded one first, I think. Yeah, so these, where are they? Don't have them. It's 2.8 mil, which should still bite a little bit. There we go. So there's our, what are they? They are, oh, they're still hex. Okay, so we're going to use these ones right here. The black ones, they have a thread on them. Okay, so now we have our mount. Our crossbar doesn't fit. That we'll fix. We can, in the short term, I'll make one that fits, and then we'll have to realign, right? But we're gonna screw these in. I'm gonna, oh, the most exciting part. You guys excited for the most exciting part? So here's my little table, right? So there's our pulley or our shiv, right? So this should be the most exciting part. Can we get it to fit? Or is it too tight? I didn't even mark the size like I should have. It fits. Oh, and it's a light interference fit. Oh, ho, ho, ho. Like a glove. It might be a little bit of a pain to get off later, but that's what we want, right? We want it on there tight. Now, we're gonna just hedge our bets. So I'm gonna take out the controller. So I've got my controller out. I got screws for it and stuff. I'm not worried about that. I have a spare screw with it. Thank you, Bambu. I like spare screws. This is hex, so I need to get my hex driver. Now, should we just be weirdos and see if our driver from the let's see if our driver from our Snapmaker set fits first. So we'll get the little bitty guy out, silver one. I believe this. Yeah, it's the gray. It's the gray from the Snapmaker set. And then we're gonna take out one of these screws. Now I am so afraid to open this because it's gonna spill, and I just won't be able to find the dang screws because black is my enemy. Black, yeah. Okay, so there we go. So there's our screw. There's our driver. Our driver's too small. Okay, let's see what else we got. Let's see what else we got, right? Let's not get too excited. So we got those. We know those won't fit. We got the red driver. There's the red driver. Is the red driver the right size? Is the red driver the right size? The red driver is the right size. Okay, so here we go. This is super exciting. Okay, now self tappers, they kind of cheat a little bit for you because they'll cut the hole. Now that's going to be too big. So because it's okay. It's going to push us back a little bit, which is fine. That's fine. And it fits, it fits. Okay, so we're just going to take the short end, turn it in, because remember we're cutting threads as we do this, right? I wish I had a rubber band. Oh, I do have a rubber band on my desk. Does it fit on my pulley? It does not, so we'll have to make a bigger pulley. Oh, it does! It fits on my pulley! So we'll just screw that down. Okay, we're good there. So what we're going to do is we're going to go, this is the fan control motor. So we're going to plug our fan controller, what do they call it? The fan speed controller. So there's our plug-in. We'll plug into a USB that I have available in front of me. And it turns! Turns a little wobbly. Probably not on there right? So we'll unplug it. But we're close. We're not perfect, but we're close. So we got our fit. That's fine. So maybe that's not all the way seated correctly. So we have rotation. We have a motor mount and rotation. Now what do we build? It's a little lopsided. That's fine because the rubber band will pick up the slack. But our mount works. Now we got to redo the crossbar. Now what I'm probably going to do is just make another crossbar and cut the circle out of it. Now what I could just file that. So I can turn my speed down. I'm at 5 volts, right? Instead of 8. It's plenty strong. So what do we make that we want to move? I guess we just repair the base to start with. Right? We fix that, and then I make a new cross member. And while we're doing that, we think about what it is. But the screw holds it great. The frame holds it in good position. We can go a little bit bigger on our diameter of our hole for the middle for it to fit over the drive shaft or the output shaft technically, if you want to get into it. So now I need to look at this and I need to realign everything in the drawing. And we'll just make a bar that fits, right? Like for now. Although we could redesign it, but still need the bar to fit. So we got a drive motor with an output, a small diameter output shiv. Perfect, right? So now we got to go look at this. This can just be one color because it gets me confused. White, not a big fan of white. Let's change the background as well because it's super bright today. That brings all the tones down, right? So, okay. So now we know. Make a motor move the truck. Okay. I don't have a battery though. And then I won't have any way to stop it. Does that make any sense to you? But we can do that. Yeah, that's like the next step. That would be one of the smaller motors. But again, I don't have any, because it all plugs into USB. I don't have a USB motor. Or, sorry, I don't have a USB battery. I have motors, right? Okay, so let's get rid of this. Actually, let's copy this, and then we'll move it aside. Then we'll ungroup this. And then we'll make the holes align again. These are the wrong size. These need to be 4, don't they? They won't be 4 because we stretch things, right? So it's like a half a mil out of size. So that it does matter. It does matter if you're wondering. That looks about center to me. This can get out of the way for now. This gets deleted. About right. And then what's our gap in here? We'll take this back. We'll put it to one edge. Give it a little bit of float. Because we have to, like I said, we have to remake this because we have to change the whole alignment. Now what we can do, so you can see here we're clear of the base, but we have this hole in the middle. So we have to take this, go here, align to that edge, and then just shrink. Oh, maybe I guess we want to come down in the middle. That looks kind of like it's in the right place. It is not. This could be smaller. A little bit. Oh, I know what we can do. This gets solid. This gets locked, or we join these, and then this becomes locked. This is already locked. This is ungrouped. Okay, so we ungroup this. And then this aligns to that. Center, center, and there's our cutout, and it looks okay. I think that looks okay. So then we lock the cutout. Then we select everything else and group that. Then we unlock this, select this, unlock this, select this, group this. There's our cutout. There's our little stubby cutout. Gives us some space to push it on. Okay, so we're going to print this. So this is the new motor crossmember version 2. Crossmember. When we export that, we'll put that on the machine in the short term. So we have a base. So the next step, I guess, is, so we have a base to start turning things with this. But if you want to do a motor into a vehicle, I'm not really, well, are we looking to adapt a pre-existing vehicle? You guys aren't looking at me. Are we looking to adapt a pre-existing vehicle? Because if we're looking to do that, then we'll do a bunch of motor renders, and then we'll have to redo a model. I just don't know, how do we get the rubber band around a shaft that's printed in place? Right? Like it's the same like with, with engines and stuff. So how do we do that? Let me think about that while I print this, okay? This will be like 5-10 minutes. The shiv is good. I want that cross member because I don't need this one anymore. Do I do a cross member in a different color? I do have I have Polymax on there. File, new project. No. So we'll get rid of the original cross member. So we have the motor mount, the shiv, now the cross member version 2. Slice, 10 minutes, and half of that's probably startup. Yeah, the model printing time, 3.5 minutes. So it's just startup for the machine, right? So we'll go in here, we eject the file. There we go. Eject the USB. Always when your Bambus, they're not plug and play, so always remember to um, eject the USB drive. Now, if we had the Voron going, it'd be a different story now, wouldn't it? We can print stuff on the IDEX. Okay, so that's good. It's ejected. Okay, so we're going to run this. Now, how do we get... The only thing I can think of, which is very doable, I think. Should we go look at it and try to figure it out? Because I have a way, I think. And what we do is we make the rear axle. Let's do it in blue just in case. That way we know, right? We won't get too confused. So what we can look at, let's look at that. Let's do the thing. Now, with this it's going to be kind of a problem. Do we use a different motor? Okay, so like this is the 90-degree, I guess I should label it correctly. 90-degree should be the USB or something. USB 59 RPM. So maybe we'll do the 59 USB 59 RPM motor mount assembly, right? And then we can do different shivs for it, but we'll save that. Okay, so now we don't need this anymore. That's our new plate, and it looks okay. This we don't need anymore. This, do we have a spare? We do have the spare. Okay, so but we don't need the spare. We need this. We need to get rid of this and this because these are wrong. This is now correct. And this is one color. This is one color. So then we'll copy this, and that's now our motor. Okay, so that's our motor. We know it all works. Muy bueno. Excelente. Yes, my Spanish is terrible. If you speak Spanish, you go right ahead. You can correct me. So it all works. It's all good. We could actually slot this and do a bunch more to this, but we won't for now. I put that aside in the box. Now, see, I don't know how we can fit that with everything we've got there because we can kind of turn things and stuff. So let's just, do we do another motor render? But nothing's a 90 degree. So let's go back. Maybe we just do it on the frame. We just make a frame again. But I don't know the height. I don't know the stretch distance of this. I guess if I just fold it in half. Because we could mount a regular motor. Like, I don't really know. So 70. It says 73, so we went 74 between centers. Is that right? No, because I have to, what is it? I'd have to figure out belt length, but let's say 73, right? Which is not crazy impossible to do. So I think what we need to do, is take one of the motors that we like. We do have that 90 degree output, but it's super high RPM. These are like 1,000 RPM. Like, that's fast, man. Like, it's just gonna rip and then smack into stuff. 1,000 RPM. Single 25 RPM worm gear. That might be what we want. Because remember, the ratio of the diameter of the sheave on the axle to the ratio of the output sheave, right? Because you try to get the ratio, because we could determine it, right? So if that's 5 and then the center of that's 8, that's, what's the percentage of that? Anyway, we'll do that math in a second. But okay, so we have a 25 RPM. I need a cabinet for all this stuff. 400 is going to be too, like, this is all going to be too high. 150 RPM, it still seems really fast. 130, we might have to use the 25. Don't need the servo. Yeah, 400 RPM is too fast. And we don't need the magnets, although the magnets could come in handy. So let's work off the 25 RPM then. Because remember, like, so if the wheel's double the size, so if my output shaft is 8 mil, right? And I guess it doesn't matter, my output shaft is now 8 mil. It's actually 4 mil radii. So it is 8 mil. So 8 mil equals 60. And then when we go to a 10, is that right? I'd have to go look up the math, but we'll get there. Hold on. Let's just do this. Okay, so I think we have to do a render of this motor before we make any choices. But I do like that we now have an output for that, right? Instead of it just being a shaft, we now have an assembly that we can turn. And we turn at 80 RPM or 60 RPM. So, yeah. And I do believe it's 8 mil on the center. And that'd be the center of the wheel. So 8 to 10 is what? 10. Okay, so we got to do this. 10 divided by 8 equals. So it's 1.2. So it's a quarter speed faster. So 1.25 times by 59. That's 73 RPM. Okay, so yeah, so let's. I kind of sort of have an idea how we can do it. It's just gonna go ripping. So unless you got a battery, like it's gonna be a problem. But we'll do it. Hey, if that's what you guys want. So let's do this render first. Let's get close. Then we'll do a test for it. So this will be FHW N20 worm gear 25 RPM. So that we've titled it. Okay, so now we're just going to open the box. They give us some tiny screws for it. So it could be mounted at 90 degrees. Like we can make a mount for 90 degrees and then screw in from one side because the receiver, like the threaded end, the receiving end, is the gear housing, which is fine because we'll use that as a mount, right? And then we can bend our wire the other way. And we have shorter, I think we have shorter wires and longer wires. So let's just, because then we're not worried about the gears, so we'll do a render of the box with the output shaft and the motor. And I guess the little square on the end, right? So let's do that. Okay, so this can all go back in the box. I need this. And then I can actually measure the screws for the diameter of the holes we need. Let's do that. Okay, so here's our motor. Let's start with the box because the box is the easiest part. But so far we can transmit power from the USB, so that's cool. So it's 18. Start out with a box. We're 18 long. And we're going to go how wide? 10 wide. Right? Because we're doing this by this. No, that's wrong. Undo. So it's 10 tall, right? And then it's 12 wide. 12 wide. And then, so for the motor is 12 wide. And to the end plate, $17. Okay, so we need 17 tall. And what did we determine the size was again? 12 wide. And then we have flats on it. And we determine the width by, so it's 9, it's 10. So they're 1 mil flats. So we take this, we're going to turn it on its side. Right, and then we hit D. And then we need 1 mil because 12 to 10 is 1, so, or 2, and then 2 cut in half is 1. Take this like this, and then we need another one. And we're going to make that on here. And there's our new mount. and then we want everything center on center. And then the flat sides are like that. And then we need a little box on the end. Our little box is 4.2. This goes here like this. And we just make it 12.1, so we have a little bit of an interface, or 17.1. This to come up to kiss the face. And then we go one more. There we go. That's our inner lock, right? So we know the two models are locked together. Then we need a little box that is 4 wide. 4. And then it's only 4.5 tall. And then it is only 3.5 deep, so 3.6. And then it looks to be in the center. .6 from the top. Here we're going to go up to the top. We're going to go center. Need to move it out 4.3. 2. That's not right. So that should just come back, I guess. Just come back. And then we need to go down. All this stuff goes line center. No offset. This needs to go down. Oh, that's why our problems. Okay, so we need to go. We weren't doing what we're supposed to do, so we need to come down 2 mil. Perfect. Yep. Okay. And then need to then do the shaft first, I guess. Then we're gonna come here. Well, we can do the holes first, I guess. So it's easier to measure the screw hole. Should really label these though. Not put the box. Oh, the box is already out. Derpa derpa derpa. Derpa derpa derpa. Okay, so there's the box. There's my screws. Give me 3 instead of 4. Interesting. There we go. Really careful because I won't be able to feel these. I think they're M1s. M1.5. I need to, so they're 1.4. There's 1.4, so they're M15s. Maybe that's just an M1. Need 4.5 mil, 4.4 mil holes. So I need to do this. I'm just gonna do 4.5 because I'm probably wrong on this. And I need to 1.5. So those are my holes. Then I need to measure. That's probably 1 mil. So it's 1 mil from the outside edge. Okay, that's fine. Then we'll put the holes all the way through. So we're going to come here. We're going to align to the corner. See, we're going to the corner, and then we're going to go to the corner. Right, so we're in. So then we're going to set our grid to 1 mil, and then we're just going to go in 1, over 1. And then drive that all the way through. And then we're going to do the same, copy. Come to this edge. Because we're already in 1 mil, right? So we're going to come over 1 mil. Okay, so there's our holes. And then our wire comes out the opposite side. So that's sort of, so we got to do the drive shaft now. So we'll put these together, right? And then this has got a gap in it. So this and this and this. Got to get rid of the 1 mil because we only have 1/10 of a mil as our overlap, just so that the models come till we kiss the face and then in. That's kissing the face 1. There we go. Okay, that looks good to me. This needs to come in a little bit as well. In like that, perfect. So now these are all solid. There's our holes. So now we just need to find the diameter of the shaft. Looks like it's 3 mil shaft. Tiny, tiny. But with the geared reduction stuff is always much stronger. But it means you can't overrun them. And then we need to know the length. 18 mil long. And then it has a flat face of 0.6. So this needs to be 0.6. Is that right? That's right, right? And then what diameter is that? So we could just make this like. So then this and this meet center and outer edge, and then we group it. And then can we assume that's, oh, and then we need to figure out the collar on it as well. 4 mil collar on it. How is the collar? 10 point collar. Figure out that diameter again because I wasn't paying attention. And then this is 10.5. This needs to ungroup. This needs to align to this. This and this, it can still have the big cutout to save you time or whatever, but then those group. that looks on center. How wide is this? This is 12. So 12 minus half the diameter, which is 2. 8 minus 2 is 6. So it is on center. And then it is how far from the edge? Half the diameter of 4 is 2, so it's 4 from the outer edge. So this will come to here. It'll center. It'll come to the edge, and then we got to go in 4 mil. So we're going to go to the ones just to save us time. 1, 2, 3, 4. Okay, so that's our motor. Now, so we need a shaft diameter. What we say it was a 3 mil shaft diameter? Yeah, so it's a 3 mil shaft diameter. So we need a 3.2, say 3.25. So we need to make a hole that's 3.25. And then we need to magnet it. Come up here. Sit on that little, see that little riser there? I forget what those are called, but then we just make our shaft come down to the same height. There we go there. And then we can disassemble this. Align this to this. And then we can raise this up. And oh, actually we'll just lock it. Now our motor's assembled. And now we have the diameter of the, and actually we can do some stuff here that's kind of hinky. So we can take this and bring this down a little bit so we can see what we're looking at. We then, no, we don't need to worry about that. So now we need to make a shaft cover, like an output pulley. We need an output pulley. And we can actually cheat again. Because this ends up being 1, and then this ends up being 1, and this ends up being our alignment tool. This gets locked. This gets locked. Because now we're not touching anything. Okay? So now we're not doing anything. So now we probably want a sidewall of at least 1 mil, maybe 2 mil. So we're going to copy this. And we're going to go from 3.25 to 5.25. Is that right? No, yeah. Let's go 6.25. 6.25. This ends up being 6.2. That's really big, but all right. And then this is our solid. This aligns to the center of this. Yeah, because we still need to be able to put screws in it and stuff. We can do a compression fit again, but it's not a big deal. Okay, so this then punches a hole in this. It's going to be too tight, though, so we have to make that cylinder bigger. So we're going to ungroup that, and we're going to well, that's not too bad. What size is that? Go 4. And then we this needs to be a different color. This needs to align to this. See, that looks way too big. That's way too big. So let's make this. So it's 3.75 or 3.25. What was it? So it's a 3 mil shaft. We were pretty close, so maybe it's 3.5. We'll have to try it, right? See how well it fits. Because that one on there, I may have bricked my. I may just be stuck with that pulley until I break it off or whatever. Again, we're going to take this, align this to the center of this. And group these two. So that gives us the hole, right? Because remember, like, 3D printing isn't the smoothest finish, it's not a machined finish. Then diameter of this. Six. So this is going to be too big. And half of the radius, so it's 1.5. So this should be like 2 mil. And then it probably only needs to be 3. No, because half of 6 is, yeah. So and then want it the same height as this, I guess. 7.5. Isn't it really 7.5? That. Yeah, so this is that. So 5. And then 5 from 17 is 17. Yeah, okay, 17.4. Okay, so it ends up with 5.4. So this ends up being 7.4. Uh, this then I probably screwed up the magnetizing of this. Oh well, we'll turn it 90 degrees. Yeah, I screwed it all up. That's fine, whatever. I wish I could change the face in which it magnetizes, but then Tinkercad would be like, yeah, but you can just build off that face. So let's just get this all squared up. We are super close there. So we'll come off that, like maybe that. That gives us that, but then this can come in like this because it doesn't really matter. And then this aligns center to that. This and this all align center to this. Yeah, that's right. And then this aligns center to this, top to this. So that gives us the collar that fits over the drive shaft. We could go looser, but I think we should try it. So should we put a pulley on this? And then the diameter of this should be, it looks smooth, but it's probably not. We'll do this. And then we'll bring back our cones. So output is 10. 10, so 25 becomes 10, which then becomes 1. What is the diameter? Fuck, maybe? I spell today? No. I have a rough day on the phone today? Yeah. Alright, so we need the base from the PIP truck. We need this thing over here. Lock, unlock, copy, go back to this, paste this in. So there's our truck, right? So the little gearbox will fit in the back of it, and but this is that's what we're gonna work with. And then what I need to do is copy this, and then I need to copy it again. I need to break this out. And then what's my ratio? So my outer diameter here is 11.2. We could go just 11. And then realign center. Because it's not, remember, we can be smaller than the bore. We cannot be bigger than the bore. This is our new wheel. That's 11. So if we make it a straight 1-to-1, so the inner bore of this, I don't understand the question. So the inner bore of this is 8.5, and the outer diameter should be like, I think. And then my height, because we're gonna make it, how tall? What's the diameter of that? This ungroups. This needs to bottom of that. So it's 8.6. So let's assume 8.5 for ease of math. What kind of margins are we building into this? Oh, you mean for the axles? Yeah, the axles is like, well, it's not. It's half that. It's 0.5 mil. They're tight fitting. They're not sloppy. I can make them bigger. It's 2 mil, right? But that's a later thing. So what did I figure out the bore was? What did I figure out the diameter of this was again? The diameter of this is what? 11, 11.2. So just assume 11. So if I make this 11, so that means that I need to put an 11 in here. This needs to be 11. And and then I need the width of my rubber band. What do I do with my rubber band? Oh, there it is. Pro tip: don't make things when you don't have any resources. So it's like a 2 point. Let's say 3 mil. So the core ends up being 3 mil. Okay, so let's see how this. So if the core is 3 mil and I want 3 mil to either side, I want this to be. The height ends up being what, like 6? 6, and it's not in a half of 4.25, 4.2, and then this would be half of that is 6, and then the core. Take another one of these, copy it, I raise it 5.5, and then I mirror it upside down, and then I put. So this needs to be This needs to be 8.5. 8.5. I think I'm doing this right. These have to join. This has to sit in the center, and it should dissolve. Edge should dissolve. Yeah, so there's my pulley. Now I can probably make these bigger. So what I want to do is make this 7 and make this 7. Makes it 14. And then I need to shave off that edge. So this groups, oops. None of that can move. This can move. This can also move. And then I don't need this anymore. So then only in the middle here, I need this middle piece to be 3 mil. This and this don't need to be as big as they are. As tall as they are, I guess. So I might have to figure that out, but they group, and then this sits in the middle of that. Okay, so then these can actually be shorter. And then this gets out of the way, and then these move down. Yes, right? I think that's right. This all sits together. And that's still not right. So then the top of this needs to be 4.5? No. 4.75? Nope. 5? There we go. That's what we're looking for. 5. There's actually real math for all of this, if you're wondering. I just haven't brought out my notebook or my school book. And then this just realigns. Although, granted, I don't think well, yeah. We'll leave it. Just leave it for now. But because it spins, it should be center aligning. So then this and this gets copied. See, that might be too big. And then what I do is I guess I put a hole straight through the middle of it. Two mil. Because that's smaller than the shaft diameter. Then that goes into the middle of this. Yeah, I don't know if you've printed the print and place truck. Here, let me put it up. It's in the link. If you go look, there's a print and place truck. Because the hole it's the diameter, not the radius. So whenever you're thinking about like a hole, like a number like that, it's actually half. Like those don't need to be as tall as there. We'll leave it for now and just see, right? So, and then the only thing I can think of is like remodeling parts of the truck. But to tell you the truth, I have no way of like actually running this because I don't have a battery. And then this aligns to this. Harness check? Yeah, one sec. What? Oh, are we break time? We're also break time. Should we run this now then? Should we run this wheel, like this pulley? I think I'm gonna put it on. Is that really a question? Always run it? Yeah, fair enough. Oh, I broke the stream, didn't I? No, I'm okay. I thought I broke the stream. Okay, so I'm gonna get my harness and take a break. I'm gonna put this on the machine. We're running Bambu today. Did I print this yet? Hold on. So this is the locking mount. Yeah, I did. So this is the locking mount, or the cross member, I guess is the term. This is the cross member for the other motor we did. Settings. Derpa 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 derpa. Derpa derpa derpa. So this goes with this. It does it. It fits. Oh, it fits. It fits. It fits. Okay, 1 to 2 per. Perfect. That'll stop the motor from twisting. Although, granted, it's in a housing, so what difference is it? Let's do this. New project. No. Preview. So we need to take those 3 pieces that we just did and start a new folder. Are we September yet? No, we're still in August, right? Yeah, we're still in August. So August. This is USB 90 degree. Bambu. 90 degree. 59 RPM set. 59 RPM. And then inside this will be like mount housing, I guess. New housing. I don't know. Like, cause it's just like a way to drive things currently. It's just like, and then this one, what did we just do? We just did the worm gear. So this is now cut, back, up, Bambu. What did we say this one was? N20 worm gear. Well, M20 motor, I guess, because I don't think they have. And then this will be like pulley conversion. What am I doing? I don't know. I'm probably doing it all in the wrong folders, that's why. Take the worm gear, cut the worm gear, put the worm gear in 2025, go to August, Bambu N20, pulley conversion, paste. Okay, so that's that. Because then we have to do like a whole bunch of like other things. I can rename the file later, but I can now know where things are. Because if I leave them the way they were, it's just going to be a nightmare, and I'll forget where everything is. And then we're auto rotate. Yeah, it'll do it the way. So now we didn't shave the edges off this. I'm not sure. I don't think it'll be a big deal, but so this will take a little bit longer because it's a little bit bigger. Again, I put it at layer 1, 2. And then what we'll do is we'll have to. Yeah. Sorry, I just got into it, right? Then what we'll do is we'll see if we can mount this inside the car. They're really small screws though, so it's kind of like the enemy of my hands, but so I'm going to start this. It's like a 10-minute print. Oh, I think I broke the SD card. Uh-oh. Don't reach into your machine like I do. Reach around your machine. Insert this. Settings. Okay, so it sees the SD card. Print files. Scanning for files. Hopefully I didn't screw it up. Well, it's taking a long time to scan. Oh, no, it's okay. There's the worm gear adapter. Next, we'll make it orange. Okay, I'm going to take my break. I'll leave you guys with this. And then we'll go from there. How's that sound? Yeah, that sounds good. Good morning, good afternoon, and good evening. Welcome to the Free Heathen Workshop. My name, of course, is Maker Millwright. Welcome into my laboratory. We're just doing some experimenting. So the next thing we do, since we've done the pulley, is we now need to make a housing. We need to do I don't need this anymore. We need to make a housing for the motor. And that's going to take some brain power because this is small. Small, small, small. More than enough to turn the car, I'm sure, but so I'm not sure what I want to do. I don't really want to make the whole car right away. What I think I want to do is make the the center of the wheels, take the wheels apart, right? I basically just want to I want to just use the cones and the center. Cuz what I want to do is make this parallel-ish esque. I'm not really sure how to do that. And I want all this to be on 90 degrees. That's weird. What did I hit? Did Tinkercad like do something when I wasn't paying attention? Did they just update? I think they updated when I refreshed. Interesting. Bundle Union? Finish sketch? Is there I didn't even know there was a finish sketch option. What? What is this? I don't understand what any of this means. What do you mean for toolpath? I don't understand. I think Tinkercad just like flashed a update. Cause I can group things now. As a like that's a bundle now. I don't real what's a bundle? I have no idea. I do not understand what that means. Yeah, but there's always a talk of Tinkercad updates. I didn't realize it was yeah. The toolpath lets you draw a shape. When you're done drawing your shape, you press finish sketch in the top right hand. I'm sorry, I don't understand what you're saying. I don't think I understand what's going on. This says that these are two separate items, I think? Oh, I never use this button. The sketching tool? Yeah, see, I don't need the sketching tool. So you're saying this crashed? I don't know. Maybe you need to refresh. These screws are bitty. I don't really know how I'm going to make this work. This is interesting. Yeah, yeah. Yeah, see, I don't use this. I don't need to use the sketch tool because I just make things fit, right? Like, these screws are so small that come with this. Like, I don't think I even have a tool to turn these. Let me get my toolbox. Right now, we're just using a mild interference or a compression fit. Like, we got no screws and anything, but we're gonna have to use screws for this to hold the motor still. Like, I guess we can make like a housing for it. We could try that. You guys want to try that? I don't understand what you're saying. Yeah, that's pretty wild. What do you mean run it anyway? We have to either we have to design something so the screws fit, or can't. I hate stuff this small. Um, like, let me look in the box for other screws then. Make it work. I'm working on it, man. Working on it. Sometimes it's a little harder than I make it look. See, these are really small. Yeah, yeah. It's just like using the magnet tool. Okay, sure. So you're like if I come over here and I take the sketch tool and I put it on this face, I can then trace the... I guess I can't. It's too small. I can't go in between these lines. I can't rotate, can I? Yeah, I don't know what stroking settings are, and I don't know what open path are. But then I can't align, like I can't move anything? Oh, I see. If I take the snap grid off, though. And that'll give me my measurements. And then what's this? I don't really understand, but that's okay. It's nice that you can bevel corners now, though. Yeah, I saw that. Yeah, it's cool that you can bevel corners now. But you can't bevel in the good way. My hands just won't do it. Hold on. So that wheel just finished. Let's see if I can get some pliers to open this bag. I don't know. I think I mostly draw artistically, so it's like, yeah, still too hot. Basically, you have to watch a bunch of tutorials. You can bevel flats easy enough with it? Okay. Basically, what you're saying is I need to watch a bunch of tutorials. That's fair. Sounds too much like work, though, if I do that. Am I wrong here? Okay with being wrong. If you're wondering what I'm doing, I'm filing down the teeth of my pliers because they're not closing correctly. They are high in the middle for sure. Getting there. Well, let's see what we get here. But I can't get the bag open. My hands are just not behaving. And these ones are super wild too. Nope. Nope. Ah, I got it. Just had to do some filing. I keep getting dinged for that Snapmaker commercial for the U1. I was like, I'd love to try a Snapmaker U1. Send it my way. Okay, let's see. Okay, so these are bitty bitty screws. They're kind of a war crime against someone like me. They're bigger than I thought they were. That's way too big. I haven't seen anything on the new toolhead. I saw a post on the Discord, but I didn't really look at it. They're not Torx, these are Allen key. No, I don't have anything. I don't think I have anything small enough to use the stock screws. So maybe we just have to build a clamp? Like sometimes you get a star to fit, but yeah, I don't think I have a driver for these. Haha, Snapmaker to the safety again. I'll have to go look up what size diameter that is. Okay, so. I'm working with the motor. And I just want to see how much thread I get. That thread's in okay, so what's my throat here? So I could go 2 mil wall. It's not the worst idea. Oh, don't feel too bad, 23. I don't get all the wild stuff. And I don't get all the wild stuff, I get some stuff from time to time, and sometimes I get support from manufacturers, sometimes I don't. Sometimes I ask and they say nothing. It happens. Like don't feel bad. At least I have a driver that can turn these screws. Right? That's what I was worried about, is I didn't have a driver to turn these. So like I guess we make a housing first. Because we want to do... I just don't really... I do know, but I don't know. Make sense? I know I want to put the... Yeah. Do I leave this alone for now? And just work on something else? Like... Do I take this? Yeah, it looks like they changed the interface. So I double this one. Group to that one. And I double this one. And I group it to that one. No, I'm not sure that's right. Oh, I see. I see now. I get it. I get it. I get it. The bundle feature's interesting. So then... Yeah, comes the rooster. That's it. I like that bundling thing. That's interesting. So that makes a seat. And this goes to this. I have no idea how well this will print, but that will work. So that makes my screw seat. That bundling option is interesting for file exportation. This doesn't, because that's, we've been bundling stuff sort of. And we can just cut this. Because we're going to print it in the flat. And since when did Tinkercad make noise? I'm not, like I said, I'm not huge on remixes, but yeah, I can do that. Give me a minute. I'll send it to you. I'll bring it up. Yeah, Tinkercad makes a noise now. I never noticed before. Oh, it does when you select stuff? It makes noises, unless I'm just hearing things. Could be. I do spend an awful lot of time alone. Yeah, maybe I'm hearing things. I don't know. Nope. Yeah, that bundle option is kind of neat. Didn't know I was streaming? I post on the Discord. Yeah, we've been on for a while. Sorry, you're staring at my hands. Actually, I should be taking a break. Well, I see this stuff as well. That's why. Yeah, it's weird, right? I should take a break soon. Give me a couple minutes here. Okay, so this ends up being sort of our sample, right? Like I can change the frame and stuff. So if I put this back solid, something like that, right? Dude, built over bot. You just keep doing you. If you can make the show, you can make the show. If you can't make the show, you can't make the show. It's YouTube. If people like watching me build stuff, they'll like watching me build stuff. If they don't, they won't. If the numbers don't go up, I just won't do it. I'm more popular on Twitch, and I don't mind that. Doesn't hurt my feelings, right? I don't mind that at all. If YouTube doesn't create an environment for makers, then there's nothing I can do about it. Well, Bundle is interesting because Bundle puts like things together in an interesting way, right? So there's that, right? But now I have to make a hole inside here for the belt to run. So what do we want to do? Like 4 mil wide? Because the belt's 3 mil? Well, yeah, that bundle feature is new. That's not group. That's totally different. Like totally new. And that's very interesting if you ask me. Like what do you think? Like a 4 mil belt? Like cuz the belt's 3 mil wide. Like that should give us clearance and then I guess just trim down these sidewalls, make them square. Yeah, it's cool, right? That bundle feature's cool, man. And then just cut these off square. It might make the wheels act funny. I'm not sure. I never realized, like I never really looked at the pockets, right? So there's our belt channel for the rubber band, but it may get stuck in there. Oh, it's working well for you? Good. So these end up being like 3 mil, and then we use the self tappers. Say 3.10, 3.1, so we can clear the threads. Yeah, it makes. I guarantee you, it makes noise now. It didn't make noise before. I don't remember ever hearing anything from Tinkercad. See, so now what I can do is, okay, so I can take these, group this, right? Then I can take these holes and bundle them. And align to this. No, I can't. I need to unbundle these. I do. No, these are fine. No, no, hold on, hold on. Although I do need to change that backing plate, but so maybe I'll do that right now. You don't? Every time I go over a point, it makes a noise. Maybe it's just feedback in my headsets? How long is this? I think it's funny. Every time I work on something, you guys like work on something else. 73. It's funny. Like that's even if I take it at 70. Well, it needs to be 70. It needs better tension. That's how high up the motor has to sit with the rubber bands I have. Like this has to sit like, oops, undo. Like that, I guess, or comes up like that, and then it comes out like I'm not saying it's impossible, but it has to come out like that. And I don't know if it's better like and then that or whatever. Oh, I do have a game open. Ha! Ha! I totally did have a game open. I had Schedule 1 open. That'd do it. That's awesome. Good looking out, 23. Good looking out. Uh, it's how it works, doing 5 things. Now playing a game, watching a stream. Yep. Yep. Facepalm. Oh, you got piled, did you? What do you think of it? So like that, like that's pretty high. Well, actually, it's not. I just wish I had shorter rubber bands, but it's good as good, right? It's good, right? Well, let's look at this. Let's look at this thing. I don't know if this is going to fit on the shaft. And I haven't done the math to determine how fast that spins, but so it fits, and it fits nicely. It's a little slop, but that's okay. It fits way better than the other one. I think maybe I made the other one tighter, but wait and whoa, whoa. Do I have 3 points? Oh, just 2 points of contact. Have I told you guys that like small screws should be a war crime? So I can do that, and I actually can get a 1.5 mil wall on that. But it's not, it won't be print in place anymore. Like, it's gonna need supports. Like, you guys, like, alright, people won't like it, but alright, I'll do it. Fine, I'll do it, it's cool. I'll do it. I can actually make this smaller too. Okay. So, nobody's gonna print it, but alright. Let's do the test build, I guess. Yeah, well, Jayton, those are like M1 or M1.5s. Yeah, but the tribe won't grow if people don't support it, right? So you make a good point, but it's just like if I can't grow, talked about this before. Remember, it's all about like for me, it's all about making the models, man. Ah, what am I doing? Ah, it doesn't matter. Whatever. These like 1.5, so these need to be now 2. So I need to copy this. What's that shaft diameter? they're 1.5, so 2 makes it clear. But how big is that cap? 2.8. So if I go 1.75 then. See, it's not going to clear, so it has to be 2. Oh yeah, I should be on break, yeah. Alright, I'll take break. Yeah, so we're working on crazy hard stuff today. We did this. So this is the new motor mount and pulley for the USB. And then now we're trying to mount a motor to the print in place models, which will no longer become print in place, which is what. Anyway, it don't matter. Let's go. I'm gonna take a break. Good morning, good afternoon, and good evening. Welcome to the Free Heathen Workshop. My name, of course, is Maker Millwright. Welcome to my laboratory. Thank you for being here. We're designing a random thing. We're trying to get the print and place design to roll, but we'll do it. We'll do it. We'll do it. All right. It's gonna need supports now, but that's just the way it's gonna be, I guess. All right. So let's get back at it. We're working hard here. I will do another plate. Let's do this plate first. So this should stop it from twisting. And then and then I want to be able to adjust that motor, but about that later. So we got to cut a throat for this. And our throat for this is 6 mil. So we'll turn this. A 6.2 block. That'll give clearance. This can come down. I don't need this one. Do I? No, I don't. That was a good song, and then YouTube canceled it. This. Quaker City Nighthawks. So that, like that, and then this, copy, and that meets here, like that. So this and this have a hole in it. And this and this have a hole in it. Don't need this. And then oh, I don't understand what's going on here. This group, that locks, and then the pink one is locked, and then this, this, and this group. And then this stays where it is, but it's locked. This gets locked. So there's my motor slips in, screws in. I got lots of clear. I should have lots of clearance for the belt. So do I just do a bar? Ugh. I need a theme song. What do you guys think my theme song should be? And I'm not talking the ones from Zach. I'm talking about the mainstream ones. So this then prints like that, and I can't. That should be parallel to the drive. Unless I put another roller in, but I don't want to put another roller in if I don't have to. Do I make this on a bar and then T-slot it in from the back? Because then it goes like this, and then it's got a T-slot, but T-slots don't print well in the vertical. I just don't know. And then if I see, I need to put triangles here, but see, I can't go any more thinner here, and I can't move because I don't have a long enough shaft. So ungroup that. I want to bundle them, and then if I bring it down, like how far down can I go? So then I make this shaft longer. And do I make, because I can make that pulley longer, right? Like I elongate this throat, but, and then this comes down like that. It's going to put a lot of lateral and horizontal pull on the pulley. And this doesn't need to be nearly that. Like it can be, like this can be hypothetically hidden inside like another part. Oh, it's making my brain hurt. right? Because this can then have triangles on it. But see, like, I want to be able to adjust that motor, because ideally this whole thing should come like way down. Like there. Even closer, actually. I think that's about as close as you can get, but like that, right? Because you can assemble everything. This is to try and drive a print-in-place vehicle. Although, which is no longer print-in-place, but... Because everybody said, make something roll, right? And this is like my rolling frame design. But that's where it should be. No, it's powered, man. All that gearbox you see is this. Yeah, it's powered. Like like, can I come out? How far out can I? Yeah, I can probably make that throat longer. It's just, yeah, that's why my brain hurts. Like, not to be like that guy, but that's like why my brain hurts. I'm always up for a challenge. I might be a little moody about it, but I'm always down for a challenge. Because I don't like to fail. I'm one of those people. I hate to fail. I like to be. So that's like. So now, like, what I can do, like, for a sample, because I can re-import all this stuff, but basically what I can do to sample it. That's why I always save the center. That's why I save these wheel configurations. And then I can just go like this, right? But I don't have the rubber bands. And I don't have rubber bands from Maker Supply. Where do I go? Look, hardware kits? I don't know if Jayton's here or not, but that's cool. That's cool, man. And they have rods that go with that, I assume. That's a universal joint, right? Oh, those are cool. Yeah, these are the ones I told Jayton to use. Those are cool. No, there's no rubber bands in here. Let me show you. Let me show you what you guys, if you don't know what I'm working on, let me show you what I'm doing. I'm using this kit. So I'm using this kit right here. The kit that I won, like we won all those points here on the channel. This is what I'm using. So that's why I'm staying within screw sizes that I know that are in the box. That's why I worked on this motor drive first. Oh yeah, this is all your guys' fault. Don't blame me. Like this is all you. This is all your guys' fault. You guys are like, make something cool. I was like, okay. And then I didn't realize like how much fun it would be. I'm gonna add the link. Yeah, like this is all. Don't blame. This is all you guys. You guys like do the thing. I'm like, okay, I like doing the thing. Yeah. So far, like the trucks I've shown, everything I've worked on today, I've put. No, no. Stop asking for cool stuff, and I'll stop making cool stuff. I blame you guys. I 100% like this. This right here. This is like so that you guys can find. Like this is a mount. This is 100% a mount. That's all your guys' fault. Don't blame me. I just work here, man. I blame you guys. You guys asked for cool stuff. You guys asked for hard things. Who am I to say no? Who am I to say no? It's not my fault. It's your fault. You asked for it. No, you did this. I gotta go find chat. There was a user in chat who loves my stuff. And when I started working on that USB thing, I was like, well, it doesn't really with all the parts for it. It won't be congruent to this stuff, right? Yeah, where is it? I'm sure of it. Yeah, it's you. How dare you guys cheer me on? This is all. Don't blame me. I make the stuff you ask for. Yeah, where is it? Somebody said just make it work. I was like, okay. I'm sure there was something in here. Listen. I didn't come up with this idea by myself. This is all your guys' fault. Don't blame me. How dare you? How dare you? You so can't blame us. I listen. If you weren't such an amazing, interesting community, I could probably ignore you. But you're not. You're friggin' awesome. You're friggin' friendly. You just do your best. We're just the heathens that run the world. It's true. I listen to you guys. So if I get moody or cranky, that's not your fault. Absolutely not. That's my own fault. But me making the weird stuff, I blame all of you. I 100% blame all of you. I 100% blame all of you. It's your fault. Like, I haven't even made a mount for this thing to see it turn, like, just for funsies. Like, you want to see what we did earlier? Let me put the screws in this. I blame you. I'm innocent in all of this. I'm 100%. You can't blame me for this. I'm innocent in all of this. I am but a simple mechanic doing simple things. Dare I say simpleton. Listen, I listen to the animals because the animals know what's cool, okay? Listen here. Listen very carefully. I listen to the animals in the zoo because I ain't no zookeeper. Whatever you gotta tell yourself at night. We're basically a bunch of mental escape patients. You're not sure why you're listening to us? Well, because who else? Nobody else wants to talk. It's your fault. Yeah, if the sane people came and talked, maybe, but they don't want to come and talk, so I listen to the animals. I blame you. Don't even look at me. I'm innocent in all of this. I am but a simple maker. I am but a simple maker who makes things. I blame you animals. Oh, look at that. Snapmaker, again, you saved the day. Don't blame me. I'm innocent in all of this. I'm just doing what's asked. This is 100% the animal's faults. I honestly though, I do wish I had a shorter rubber band. But can we look? Do you guys mind looking? I'm gonna put this together first. I'll show you what I did. I think that screw's too small though. I think I went to a bigger screw for this. Yeah, it's too small. This falls in. Because I think these are M3 holes, and these are like M1.5s or M2s. What are they? Yeah, these are M2s. I probably should have made the holes smaller. We'll do it on the revised mount. But I blame the animals. Don't look at me. I just make the thing. I'm just in the zoo. I'm just another animal in the zoo that everybody's like, go build that thing. I'm like, oh, all right. Oh, come on now. Don't be like that. Ah, I got it. I got it. I got it. Not so great on the hands, but I got it. Yeah, like, so what happened was, for those of you new today, who haven't seen the rest of the show, so I was just like doing my thing. I was like, oh, I'll make this little speed controller so we have a thing. 2.5? Maybe that'll fit? Well, I think these are M3 holes though. Ball bearings. So I don't need these, do I? No, this is springs. I don't need these, too small. Hey, don't look at me, man. I just work here. What is it? What's everybody's defense lately? Oh, I just doing my job. Well, I'm just doing my job. See, if we could sneak a spring into that design, though. Yeah, I try not to use the nuts just yet. These are too small. These are gonna be too small. Dowel pins. Don't listen. Somebody's got to be in trouble here, and it ain't gonna be me. I'm just doing what the animals say. Helical springs, more helical springs. These are the M3s, but they're gonna be not the right M3s. I don't want to go digging, like I want to use this stuff because I don't want to go digging through my awesome stuff I got from KB3D because I know there's screws from KB3D. I know there is. Maybe those holes are just too big. I can even shove a dowel in there, but I don't want to shove a dowel in there. Yeah, I think I made these holes just too big. Just by looking at what I have. A lot of M2, right? Which is fine. M2 is like a war crime in itself, but listen, listen here. Let's be very clear, okay? I am but an innocent maker in all of this chaos. Maybe we use those self-tappers again? Because these are M2 self-tappers. Those are not what we want. I gotta be careful. I don't want to mess everything up. Man, there's some big springs in here. I love it. Also small springs. I wonder if Jayden's here. I wonder if he ended up deciding on any of these. The balls. The balls are cool for making. Tell me these are M3s. No, these are M2.5. Maybe these will fit. Maybe these are the ones we want. These ones I can use to, I think, do the base, but that's not what I want. Listen, I'm not here to offend the animals. I'm here to keep the animals busy so the animals don't find something else to do. You know what I'm saying? You know what I'm saying? If the animals are too busy critiquing and being interested in what I do. Oh, are those? No. They are fantastic. I actually have more of those M2s. It says that's an M2, but I don't think that's an M2. I think that's, maybe it is an M2. Maybe it is. We haven't even got, we're just like fiddling with like turning stuff right now. We're not even into the fun stuff yet. Maybe these self-tappers. So those are kind of our choices. Because I'm pretty sure some of these like rods and bearings will fit together, which actually sounds really exciting to me. Although they might just get stuck. Machine screws, yeah. Those are not machine screws, they're countersunk. That's okay, Bambu. You and I can disagree. Listen, listen, okay? I'm not here to tell the animals what to do. I'm just here to keep the animals busy so they don't eat other things. These are what? These are M3s, but these are too long. Alright, hold on. Let me just catch up on chat. But I blame you animals. Don't look at me. I'm innocent in all of this. What do we got here? All right, what do we got here? Listen, you listen to the mad ones because the mad ones might have some good ideas for once. Well, if you don't blame, if you don't want to blame, if you don't want the blame, then don't work. Then don't do the work that that can't be done. Well, it's your own fault. Listen, anyone can do what I do. I have a couple lender bands. I don't know a couple of bevel gears. I have a direct motor drive. You could probably mount the motor right on the back of the truck. Well, I want to mount it. Well, I want to mount the motor inside the truck. Like that'll be. I'm not. I just want to get it to work right now. So I'm just like, it's my. Don't look at me. It's not my fault. I didn't build the thing. Hey, 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 why you gotta be like that? It's not my fault. It's my first day. It's my first day too. Don't look at me. I'm not the mod here. It's not my fault. Yeah, but you might end up being. I don't know how to mod you 23. Can I? Oh, hold on. Hold on. Hold on. Oh, there is. Okay, thank you for posting that. So we'll go and look at that, right? Hold on. Hold on. Oh, everything on my dashboard just refreshed. All right, so let's see here. Can I? No, because I can't type here. Let's try this. Can I go? Is there slash mod in this? No. No. Is there a bang mod? Oh, YouTube. Dearest to YouTube. Nope. Dang it. I can't. So I can't. Okay, so I don't even know how to mod on YouTube. Okay, let me catch up with that back on chat though. Yeah, no, like Mr. Thomas there. Yeah, I can. So if you don't know, so the print and place truck, it has some sneaky stuff inside it. Like this is a fair movement. Like what we're doing, like it's fair. Uh, uh, I'm the 23rd temp replacement. Keyword temp. Yeah, I'm a temp. I'm just an apprentice. Talk to my journeyman. That's such a that is so good yet so dirty. If you are not here to offend the animals, then well, pitter patter, get at her. That's listen. You're the only journeyman here, so basically it's all your fault. You're in charge by default. Why you gotta do me like that? There is no base. There is no basically. He is the only one in charge, and he doesn't like to take the blame for things. Look, I just create the things you guys ask for. This is all your guys. Don't look at me. Somebody said, okay, now put a motor on it. Who am I to say no? Put a motor on it. Really? Let's be real. Who am I to say no? Anyway, so let's go back at this. Like, oh yeah, I need a theme song by the way, guys. So I'm gonna just try these screws. Do I have shorter ones? These are what? These are M2.5, and I think that's what I made them for. Are these M2.5? They are. Okay, so these are cap screws. These might do the job. Oh, I can open the bag. Nice. Oh, that's not what I wanted. I need an organizer for all this stuff. Not because the Bambu stuff isn't organized. It's really good. I'm keeping it organized in the box. Stupid hands. I'm so worried. It's okay. I guess I can drop a couple screws. It's not a big deal. So we'll try these. I'm not sure if they'll work. Okay, so my Allen key fits. Now remember, I didn't put super deep threads in this because I didn't thread the hole. No, these won't work. So these holes won't work. So we have one more option. Come on now. Don't do me like that. Oh, nice. I did put all the screws into the gearbox for this gearbox. So I put all the screws in it just so I didn't lose them. Oh, I didn't. All but one. Big mouth. Good job, Big Mouth. Okay, so these are what 2.5. So that hole's too big. Now we'll try these self-tappers because I think I used them before. And then I'll show you like the thing I built, and then somebody's like, "Yeah, now take another motor or take a motor and put it in a truck so it runs." I'm like, "Yeah, but I don't have any like controls." Like, they didn't respond, so whatever. That's the wrong size. Oh no! What are you printing in purple? Have you won from the channel yet? Have you been on our Twitch? You should join our Twitch, because we do a giveaway every Sunday on Twitch. We're sponsored by Polymaker. I'm actually tempted to do a giveaway here on YouTube, but we gotta get the numbers up. You print everything purple? Well, that's a good choice. Come on, hands. Don't fail me now. Oh, it works! Okay, so I must have made these for the self-tappers. Yeah, I must have made, like when I was designing this, I must have known the size. Okay, so here we go. Let me just clean up, because I can't get rid of this other one because it's part of the project still. But let me show you what we already. Oh, I gotta get a light on for you guys. Hold on. It's getting dark in here. Still really hot here in Vancouver. Just so you guys know, if you guys aren't from Vancouver, it's well, I don't have that. That's so funny. When I was talking to, I called somebody today and I told them I never like I don't get anything from Canadian support, and they're like, yeah, that's pretty normal. So like I'm building off that Bambu thing. So I'm using whatever's in that kit. There's no belts, no rubber bands or anything. So I do think like the kit is great. I don't know what I would take out of it, right? But okay, so I just got to pull the speed controller out because it's part of this design. So what it was is in the kit, you see that USB drive down on the bottom? I was just like, well, we should build something around that because that's the easiest one because we don't have to do any major wiring or nothing, right? So this is, they call it the fan speed controller. I gotta refresh this. This is lagging. There we go. So there you go, right? So that plugs in to a USB drive or to a, it's a USB drive itself, right? And it plugs in, and I don't know what happened to my YouTube. So it plugs in, and then this plugs into that. So what I did on here is I made a frame to hold the motor. Now, I'm willing to make this bigger, to have screw holes and stuff, but this was kind of the prototype. Then I made a crossbar for it so it doesn't fall out, and it does screw into the base, right? So it keeps position. Then I made a little pulley for it that fits my rubber band, right? Does it go into anything? No, it fits the rubber. That's what I did, right? So then all you do for this is you could plug it in for direct speed, but I like a speed controller on stuff. So there it is there. So this is a 60 RPM motor, or 59, and I'm running at 5.1 U. Maybe that's volts. So at 80 RPM, or sorry, at 8 6 at 8 volts, it should be turning at its max speed, right? Because that's the output of a standard USB. You can get 15 volt output, but basically that should be turning at 60 RPM, right? So then we determine sizes based on that. Well, I was making this, and everybody's like, "That's yeah." Somebody said that's cool. Now make the truck drive. Yeah, maximum at 8 volts. 8 volts DC, pardon me. Correct. So the speed controller's at 8, so we can determine our rotational speed, although it doesn't go to 0 volts, so we'd have to figure out stuff, right? But basically this should be 59 RPM. Okay? And I tried to make the wheel as small as I could so that you can upscale against your opposing wheel, right? So I made that. So now you have something that turns, right? You can just plug it in and turn stuff. No, I don't want to make my own stuff. I don't want to make my own theme song. That'd be no fun. So there's my screws, there's my mount. This is all built off their kit, right? And it uses a speed controller that's USB and so on, right? Now I can make this bigger so it holds the cable down, things like that, but this was the proof of concept of the frame. I didn't want it to roll over. I didn't want it, and remember, you can mount that anywhere you want, up, down, left, right, because you have a mounting plate now, right? So I can make that mounting plate bigger so you can put the screws through it, whatever you want, right? But now the motor's held in, both by a screw and by a crossbar. I don't know. So we did that, right? So that was like the first project we completed today. And oh well, it doesn't do anything. It does. It holds it in place, and it now has an output that you can use, especially with a rubber band, right? And like we can make that turn other things. I just have to figure out what I want to turn. And because we have like metallic shafts, we have like stainless steel and brass, and I'm sure we have bearings that fit on there. We can put that in. We might have to put a keeper on the end of the shaft. I'm not sure about that. But so that's a completed project, right? Now, because you guys are you guys, and the animals are the animals, and I blame the animals for everything because I'm not blaming myself for this. Why would I blame myself? No, I'm gonna blame you guys for this. So now I have 3 screws. I think it was only supposed to come with 2 because there's like 2 mounting points. But what I'm gonna do is I'm just gonna screw this third one in so that I don't lose it, right? And it should seat all the way in, hopefully. I don't think it's gonna have an issue with the shaft. Why screw it all the way in? Because then I don't lose it. Oh, well, hello, Mr. Slack. How are you, sir? So now that fits on. Oh, I lagged out. Why am I lagging out? Am I lagging out to you guys? Can I get some W's in chat? No, I'm fine. So, right, that little screw doesn't bother nothing, but now it's in place, right? So we have a pulley attached to a motor, right? And I can put a screw hole in there. I probably should, just cause, right? So that might be another thing. Although we have to do like 1.8 mil for the hole, I guess, which is not a big deal, right? But so I've already built one thing today. Now we're on to a second thing, which is significantly more complicated. And I blame you animals for making it fun and interesting. I might mope and be cranky about it, but that's the Millwright way. You know what I'm saying? But I'm not paying attention to timers today, and I need to be. I think we have another break here. But before I go on break again, I want to show you. So we're working with this, the Essential Kit. And the only thing that because maybe I should just get, do they make another kit? Maker kits? Is there one with rubber bands and like, so this is like one of the things we worked on, right? But is there one with belts or bands? What's this? We have fasteners. We have enough fasteners now. Motorized gear ratio could be fun. The recharge kit could be fun, but it doesn't give us. We sort of, if we're gonna get lazy, we can use other gears and stuff. But again, with this one, by the looks of it, we can. So dynamic installation. This is very much a part of one of the kits I have. What is this? What is das? What is das? What is das? Power distribution board. We've got one of those. Self-locking switch. We have one of those. Potentiometer. We have one of those. We have the 59 RPM counterclockwise motor, reduction gear motor. Okay, so there's the two motors. White LEDs, worm gear motor, speed controller, wire slip ring with S1 connector. So what is this and what is this? What is das? What is this? What is das? So it's like a magnetic connector? So like that's kind of clever. Okay, interesting. Slip ring, wire slip ring. So this allows me to apply power when something's turning, correct? Yeah, that's this. We were talking about something like this on the printer. Maker can't take the responsibility for. Listen, I only make what you guys ask for. Slip ring is what I was specifically talking about. Rotational leg. Yeah. So that's pretty cool. How many volts can we put through it? Can we make a printer with it? So that's pretty cool. And then this is what is das? What is in this? This is made. You know what this is made for? I think. Yeah, make your own filament spooler, dry box, AMS stand, light, hanging light, toolbox, or temperature and humidity control monitoring. This fits you with the parts that you need for the impressive workshop. Well, that's cool. Not what I need right now, but that's cool. Okay, so no, we cannot use it to make a heater. Okay, never mind. 5 volt DC, 1 amp. Oh no, no, I don't think so. So that's Slack. That's what we were talking the other day when we were working on the machine, right? That's what I want though. So what's the difference between that and a magnetic one? Can we use this on our heated build plate? Like, will this turn or will it become a problem? Again, I know this is super low voltage, right? But this I like, but we already have all this stuff, I think. I like that. I think that's interesting. This is cool. I don't need a dry box right now, but I'm not saying it's not possible, although I do like this. Although I need a double connector. I basically need that, but I want to screw it in through a piece of Lexan or polycarbonate. This has got a splitter on it. That's cool. So this is that gear set I'm interested in. This is cool too. And then you can jump out circuits so you can do stuff. The one that is magnetic, the key is fully enclosing it in an insulating layer. So will it turn though? Like, can I turn on the magnets? Oh, it'll wear the faces of the magnets, won't it? Never mind. Because is that safer than a slip ring conductor? I like that splitter idea though. That's cool. Because you can have an on-off and a potentiometer, no? Anyway, so this is the kit we're using though. And we're like really basic right now. But we have no... The problem we're running into is what about rubber? Like, do they do a rubber band kit? Or do I just have to look up? Ooh, plastic differentials? That's cool, plastic differentials. Single axis joystick. A lot of this stuff you can use to make printers. Yeah, see, if we had the lithium battery kit, it'd be interesting. No, that's just the charger. What was it? There was one, right? There was one kit. There's a kit, right? This one. Because the battery, we'd use the battery. Do we use the battery? Yes, because there's in out, right? That's what that is, right? In out. So this goes into one side. There's an on-off switch, and then the out would go to the hub. We have to still hook up the hub, just so you guys know. But I just don't know about rubber bands. Like I'm stuck. Like right now, I'm using, unless I use a lag pulley, because to put this under tension, I need to be about 76 mil from center. Okay, let me take my break before we get too crazy. But yeah, you can see here, like ideally, this would be the distance. Like 33 mil or 35 mil, because we, you know what I mean? And if I put it at an angle, it's better if it's vertical just for the interaction with the model. Because if I make that a hole, you can see, right? Like there's a slot all the way through, and then it goes to a round under the wheel. Anyway, I'm gonna take my break, and then we can talk about it. But yeah, like this is, don't blame me. This is all your guys' fault. Don't blame me. I'm innocent in all of this. I just make the stuff. So I'm gonna go put this over on the thing. I'll put this on the display for now, and then I'll be back soon. But I love you all very much, and yeah, I love the challenge. There's a place that sells slip rings for various applications. I'm seeing, so 15 amps should be more than enough, and we want to run at what, like 12 volt DC is what one of those heater things is. Anyway, I'm gonna take my break. I'll be back soon. Good morning, good afternoon, and good evening. We're into overtime because I'm having a fun time doing things, and you gotta chase that feeling, right? So we're gonna change our hole. We gotta change some hole diameters. It's fine. Um, but we're using the build kit from Maker World right now. Uh-oh, mayhem's here. Slimpering, yeah, electrical. There's the one that's magnetic. The key is enclosing the insulate. Yeah, we can make something, right? Well, yeah, because I've used Yeah, that's also why I'm still up. Oh, okay. Sorry. Um, I could probably hit Walmart tomorrow. There's still no mods post on the Discord an event for tomorrow for not tomorrow, Friday night. Friday night on Twitch, so I don't know. There's no guarantee. It depends on how I feel. If you guys want it, you gotta say so, right? Um, but yeah. So what we're doing here is we're designing some stuff. I'm gonna go grab this cozy. How's it doing TPU? Have you run it in TPU yet? The J1 does not like TPU. We have to work a solution for that, and I don't really want to design something for that, but I may have to. So yeah, this is what we're doing. And the problem right now is like the motor height, but not really. Yeah, of course you get the like and the love. Let me put this in YouTube. Of course you do. Why wouldn't you? I like when you guys do stuff. Here, I'll do you no, I won't put that in the write up. But this is what we're doing. So this is just a sample, right? You're welcome. Those holes are too big, so we'll have to change these holes, but that's fine. Um yeah, we'll have to but that's not the problem. Right now the problem is how do we adjust the motor height? Now, I'm going to go grab another file and just see something. Because ideally we would hide it, because we can do switches and stuff, we'd hide it. Oh, that's the really big one. Because we can hollow stuff, right? Like, it's not a big deal. And since we're not going down that road, right? Um, we can copy this. I don't know why I brought everything, but that's okay. I need some music, by the way. So if anyone's here is a part of the Discord, get me some music, would you? Okay, so but the idea would be, do we have enough cab room? I think we have enough cab room if we use a shorter elastic band. Like if we have a shorter elastic band, we can hide the motor and everything inside this. There's got to be a way, right? I can change the position of the motor or whatever, but or we put it in the other ones until I find a better way to do it. But this is like that would be the ideal position. Like way down here. And this can be moved up, right? Like it can be hidden inside something. Because we can make that shaft, like we can make this all shorter. We just trim that down until it fits, and then we make a hole through the center of this hub, and just make it so the hub fits down on it, as long as it clears the mount, right? Because there's a screw that goes in here. Because that does fit inside if can I rotate the motor? So I rotate the motor, can we still hide? No. But there's got to be a way, right? There's got to be a way. But we're like right now we're just fiddling with what can be done, and this cannot be done. This is all. That's our belt, right? Always, yeah, always. If you're willing to try, there's a way. There's always a way. There's a way. There's always a way to do it. And I'm just trying to see like what we can do right now, right? Because normally the motor's like in a sled. So like this would be in a sled, which we can almost do. We have screws that we got to worry about, but that's not a huge deal. And what you would do is like, I guess you push it closer to the motor. I don't know. You put a spring in here. I can't remember. It's been a long time. But right now, like it works. Like in principle, this works. If I go back and I take this. And we take this, turn it a different color. Maggot. Maggot down to here somewhere. Let me just magnet it and then we'll get close. Like, hypothetically, just mounting it in a fixed position. The only problem is we have no way to take up the slack, but so we take this and we align this to this. Can we see center on this? Can I get my center, please? There we go. So then we center it like that and then undo that. And then this comes up just a little bit. Like just so it's not sitting on the face of the thing. And then that goes up into that like that. And then this goes over here like this. We now have a long shaft pulley. I know, I know. I don't know how to get all that stuff to work over here. Yeah, there's nothing that works over here. The throne, I'd have to go look on the Discord for the throne. I don't know how to make any of that stuff work here. So there's our elongated pulley. And it should print okay. It won't be like we can do inside, we can do a cone and stuff, right? To get rid of that face, but you've got it? It's all good, sir. I got it. Okay. But we're pretty close to another redeem on on Maker World. So like there is a way. Like we can look. You want to look? Oh yeah, we were looking at their stuff. But do they do? Do springs and stuff? The springs, like we could do a spring, but again, we still need a shuttle. Do they do rubber bands? You know what I'm saying? Because that's like we're done. Like the problem is you need to be able to provide tension on that a rubber band, but my rubber band's too long. And right now this is just a sample, so it's not it's like right? And I can change the cab size. I can do a bunch of different stuff. And on here, I can qu'est-ce que c'est? Bum, 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 bum. I can. There's like a bunch of different things I can do. Like I add a switch. I can. I don't think we need the potentiometer, although it would be a good idea. We got different cable lengths, so I'm not worried about that. We got a battery. We do have a battery pack that then powers things. So again, the trick is how do you get the thing to stop? How many wires are needed to go directly to the on the rotiller? What, 2? Because the thermistor, I don't know how we're gonna do the thermistor, but because we need a thermal, we need to know how hot the bed is, right? But it's 12 volt to turn the, I think it's 12 volt to turn it on. We don't need that. We need the switch. What else do we need? We need the hub. No, that's lights. Is that the hub? Distribution hub. We could put lights on it. Like that's because we got the hub, right? So do I just, what sensors? We need some sort of positional, we can do the count on the motor, I think, but we need to know the temperature of the build plate, and we need an optical sensor, but that doesn't, I guess that pulls from the 12 volt, because it's just the backside of it? No, because an optical sensor just sees something, so it turns until it sees it. So you need an optical sensor and the mirror for it. You need the power to the disk, but you're not actually going to the disk. You're going from the rotary 12 volt into that, so it's drawing from that, and that's all in a center hub because it's not actually charging the plate. The plate's not electrified, and then we need a positional motor. Some people call them servos, but it's a motor with a position ring on the bottom of it, from what I'm thinking. But that's, yeah, yes, correct. Stepper motor with an encoder. That's what we need. Positional motor. CGS, thank Polymaker. Without them, like, we'd be so far behind. I blame Polymaker. They're so wonderful to me. So we need this hub for power to that motor. So this would work just off the shelf stuff, I'm pretty sure this would work in the cab over truck. But again, like, it won't be print in place anymore because I have to disassemble the axle assembly. Like, this has to fit. Because I have to get to the back side of this. And then the motor, well, the motor, it can fit inside. Like, it's all hollow, right? We'd end up making it hollow. I just, and if I could change this so that the bottom is flat with screw holes, and it would print in a vertical. Yeah, Polymaker TL. It's a good color. Right? Like this would print in the flat. Right? That would print. Oh, we don't have this hole in it. Hold on. How do I not have the hole in this yet? And I think there's enough clearance for the belt. Now, I could be wrong, right? But like I say, so this ends up, it'd have to print like that. I think. Like, I can 45 these pockets. This one doesn't matter. Like, I can 45 the top and bottom of those pockets, sure. But, you know what I'm saying? You're crazy, man. So that's like, we can make this. We can even make it so that this like has its own little pocket, right? And it doesn't like if it's being the problem is it uses supports. And the whole idea behind the truck was it wasn't supposed to use supports. Yeah, because like we put a triangle here. And then we just cut that all out, right? And we put a screw in through it. And you just plug it in and it turns on. Yeah, I don't need this. Nor do I need that. And then this will all turn. And this can technically be this way because that port, it might have to be reversed, but the port's on the bottom, right? Well, I got that pretty close. Yeah, because the motor, I just have to rotate this. Yeah. And technically it can be lower, right? But I can't be lower right now because the only rubber band I have is like 75 mil long. But I got that pretty close, man. That's pretty cool. And we're still getting our clearance. We do have to put a screw hole on this. Do we just print this piece then? Because we want the screw hole on the flat side. So where's the flat side? There's the flat side. So, and what did I have? M2s? M2s I had a lot of, right? Pretty sure I had a lot of them. Yeah, I got a bunch of battery stuff. That's cool. That's not like battery is like a secondary thought, really. But the problem is right now when you turn it on, there's like no timer, so it just drives. Like that's a thing. So it goes this, this, this group. And then because we just make the half moon or whatever it's called. I think it's a half moon. I don't know. You guys are like leading me down the road of making an RC car. You know that, right? Like you get that, right? So this ends up being a little bit unpleasant. But if this comes up like that, we end up with a ton of clearance. Because remember, we just need the pulley to stay where it needs to be, right? Now we can do that through a gearbox or whatever if you guys really want. I gotta measure this screw and put a hole in something, but give me a second. And then the other thing is to put this controller on it. Well, because like I was saying, like we can get a battery pack and a recharger for it, but it's just gonna run, and it may do this, right? Because like the slop in the wheels, because there's no differential in that. This is all your guys' fault, so that's 2.5, right? So if we make 2, well, what's 80% of 2.5? 2. So I could do a 2 mil hole for these screws, which is fine because I can use them all the way around. And like I said, we can cut that triangle out. Like we want that triangle, but we can make space in it. And again, like if this was removable, like if we screw the motor down. The other thing is to make it use bolts and nuts and just put eye holes in it. And that way you can push the motor up till you get tension and then screw it down. Anyway, I'm gonna do this hole and then we'll just do this. So I gotta make sure this is a hole. So there's my flat side. Whoa, 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 whoa. That's not right. Ungroup. What's the height of this thing? 21.6. So this ends up being 21.6. There we go. Now we're okay. So that's our side. This is our flat side. So now I need a 2 mil hole. I guess it doesn't really matter. Can we ungroup this again? So this needs to come up. Needs to be centered. This needs to change color because it's driving me crazy. That gives us plenty of clearance. We make this a little bit more square, like out like that. I think we do, right? Because then we have a flat spot for the screw to sit on. And that should still give us enough clearance. We can always cut that pocket bigger, but... And then this and this come to the edge of this like that. And then this can come in more. Ends up being a hole. And then, of course, we could leave the sides on it. Yeah, I guess we'll leave the sides on it. Could actually be 12-sided. Because we don't care, right? Because the screw's going to self-tap. And it says at 80% engagement, or sorry, 80% diameter, we're at 2. So, oh no, I want this lower. I want this lower because that shaft is only so long. Like, like that. Yeah, like that, because then this sits like... So this eye definitely has to be bigger, right, to fit that square bit, but that gives us room for our screw, and it gives us plenty of movement up and down. No, enjoy pepperoni. I can't boost the K-truck anymore? Yeah, like make it like, right, and we can do multiple of these shafts. But that looks about right to me. So I think we... I think we print this and then try it and then put the screw in it and see how it looks on the motor, right? And again, like this pattern can be reused. So I guess we print the pulley first and then we print this mount. Because we're back from the, like, what if we did, no, that wouldn't work. I'm just thinking, if this was on tabs, it wouldn't really have that big of a problem printing. And we could lock that tab, but we can't lock that tab because, how thick is that? Oh, we can actually. Because we do end up with a little bit of space between the motor. And can I make this parallel to the outside? What's the, oh, I need to ungroup this. No, I don't. Because it's, oh yeah, I do. So how tall is this? And that gives us a tongue that we can slip. That we can slip in between two keepers or between two panels, and we can press against the inside panel. I don't know. Let's print this, and we'll put that on the motor. Nice. Story of my life, dude. Okay, so let's do this on the Bambu. This is your guys' fault. Don't even look at me. I just make the stuff. Yeah, well, yeah, just keep doing your thing. I noticed that you got a lot of posts, so that's good. Keep making stuff, guys. Like, so there's the pulley on there now, but that pulley doesn't have a keeper, like, screw in it. Sometimes referred to as a grub screw, but a grub screw has no cap. That's why it's called a grub screw. Looks like a little grub. We'll take this. But yeah, like we've already completed one full design today. Just like to point that out. I don't know what we could use it for, but just like to point that out. All right, so now we'll print this. But I don't know. Nice. Nice. But I don't know, like, where to go from here. The only other option is, of course, to cut the hole at a different angle, but that doesn't really change much because we still have that super long belt, right? One hundred 41 layers, 142 layers, sorry. 25 minutes. Yeah. So the only thing we're missing now is like a mount for this in general, which we should probably make. I think there's washers in here that'll fit too. So I'm not. What do we do? I guess. Do we do the prototype where we turn the wheels and just say, oh yeah, we can turn the wheels? Because like what we have to do is mount the. We'd have to make a mount for the. We'd have to make a mount for the motor, which is like fine. But what do we do with it, right? Like you guys like, well, what can we do with the USB one? I was like, I don't know, turn stuff. Dude, I am like literally. Tribe's like, hey, make it move, make the truck move. So I'm like, okay, I kind of can make the truck move now. And I can put on-off switches. There's like a bunch of stuff I can do using what I have in front of me, but it's just constant run. Like that's where it stops. And I'm not sure. Like originally I was setting out to make a paint mixer. Because making gears is hard. And I'm not sure I can make gears in Tinkercad. Because I don't know how to do the interface. No, they have gears. But there's a thing called like gear interface where the teeth meet. And I don't know how to do that. I understand. I see the gears. I've never even cut gears before, let alone designed a gearbox. That's some like serious engineering stuff, guys. I'm just a mechanic. Like I'm just a dude. And yeah, I know there's other people that do it. I get it. But you know, can you Slack? Can you post that on the Discord so it's something I can look at? The reason why I'm using belts is like belts are easy. Why you gotta be like that? Why you gotta do me dirty like that, 23? I'm just so glad you guys can't clip on YouTube. Or else everyone would know I blame everything on you guys. Right now, nobody knows that. It's what I do best, yeah. But belts are easier than gears, like just ratio wise. But what I'm struggling with, I guess what to be honest, what I'm struggling with is how to mount this gearbox. Cause like you have to tension them. You cannot clip YouTube. Don't start with me. Because like we've got plenty of clearance for the screws, right? The screw caps is something we got to be concerned about. I did make these plates like right. I have to make this bigger so that it accommodates the new shaft design. So this is a must. This, on the other hand, it says I got clearance. I don't know if I believe that or not. And then if I center this, right? Because this is our drive. Our drive should be set up correctly. It is. Yeah, it is set up. It is set up correctly. So if I center this, it should tell me if I have clearance or not. It looks like it's got clearance, right? Like this could come in more. Like that, or like that, right? Because it's not a big deal. But what I worry about is the edges of this. So should I I think maybe I just make this a little wider. Man, I want some fancy food tonight. Is that weird? I want like sushi. I feel bad though. You guys got music for me? There was music the other day. What's this? This clipping me business. Cut that out. No clipping maker. I'm gonna listen to this drum and bass that was posted because that's sweet. Why you gotta be like that? Why you gotta do me dirty like that? But do you see what I'm saying here? Like, I think we need to be wider. You can't see? You can't see what I'm... Oh, sorry. I have my window really big today, so I can't see chat very well. Yeah, there it is. Well, hello. Hello. See, like, that looks like it turns well on the arc, right? But it doesn't. See how it catches? Well, sort of clears. We could go bigger. Yeah, see, I don't want it to strike, and that looks really tight to me. What do you mean, SimLab? I don't understand. I think this needs to be wider. Like that almost. I might be overthinking it, right? That's the only part. See it right there? Like that's tight. Type in, what do you mean? Here? SimLab? What are you talking about? I don't understand. Like, unless you want me to go over here and do SimLab. Not SimLab, SimLab. Yeah, I have no idea what you guys are talking about. Like, we can do this. Like, watch this. I can do this. And I can do this, this, this. And then I can take this over here. And then I'm not sure how I turn the pivot on this. Like, I don't understand a lot of this stuff. No, see, it didn't do anything. I'm screwing it up now. Like, that's turning inside the housing. Why is the motor out of alignment, though? Okay, so I don't understand what's going on. I screwed it all up. Okay, so I'm in SimLab for the all the objects. What am I looking at? Metal cup, yogurt cup, solar leaf, domino grid, soccer goal, car. Yeah, I know about the gears. I know about the gears. Like, I'm aware of these. Like, I'm already aware of these. Like, it shows the rotation in the middle. I don't really know I don't really understand, but doesn't really matter because I screwed this all up, so because I moved the motor. I don't want to use gears. But did I move that hole? Like, see, now my holes are all screwed up. Why are my holes all screwed up? Yeah, no, I get the gears. Like there are like legitimate gears like on there, but the reason I don't want to use gears because gears add a whole new layer of difficulty to it. The reason why I want to use belts and pulleys is because that at least it runs. It's okay. I can do that if you have the gear ratio and you want to show me the gear ratio, sure. So I don't know what is going on here. So they are in the right. No, it's cool. It's like we can do gears, but I don't know how to build a gearbox. I only know how to fix one. So I have to go watch a bunch of tutorials on how to build a gearbox for spacing, for orientation, things like that. Like, because if they're too tight, they jam. If they're not tight enough, they don't engage or they wear out. And you want to mesh. It's called gearing mesh. And there's a certain, at least in metal, there's a certain amount of meshing you need. And using those conical bearings or using those conical, what you're talking about is you're talking about using conical bearings like these down here, and you see how they're conical. But what's the required amount of meshing? Where's the alignment, right? And then how do I put them? So if I want them parallel, they don't mesh, right? So if I want a parallel meshing gear, right? So if I move this back, it's tooth to tooth. So how do I make them, like, how do I make parallel gears with the right amount of meshing, right? Because that's roughly where I'm supposed to be, like there. And this should go in like this. But what's the parallel, what's the meshing required for that? I see how they've got different sizes, different amount of teeth, right? But see, when I make them like this, that's what is that, a 3-to-1 ratio, something like that? What's the diameter? 18, and this is what? 11, so it's not quite, it's like what, 1.6 or something? So it's like, yeah, I've seen the gears, and there's also, if you don't know, there is, if you go to shape generator, there's real gears. And like this one, the outer radius number of teeth, like let's say 32, right? But then you get all these. That's not gonna work. That's gonna break, right? And then this is like toothpaste. This is the closest. This is an Acme gear by the looks of it. They're loud, but they work well. But you have to do you have to figure like you have to know the ratio of teeth, right? So and then you have to put a shaft in. So like let's say we got two of these side by side. So that's our ratio, right? Then you have to put a shaft in. So let's say those are like tiny shafts. Let's just say 6 mil for sake. So this has to sit in the middle of this, has to be perfectly in the middle. And then this comes down, right? But then you have to build a gearbox around these. So let's copy this. And yeah, I know there's people that do this, and that's fine for them. but I don't know how, and I haven't watched any tutorials on it. So there's your gearbox, right? So how do you drive? Do you just gear? Are you talking about do we gear? Do we gear this now? So this, right? Because this is like it doesn't matter, but um, so then do we take this and gear this wheel? Is that what you're saying? So this gears into that, and then the motor drives this. So then we put a gear on the motor to drive it. And remember, this axle is not supported, so it's floating in the housing. Is that what you're trying to say? Like in here, it's just floating. That's why it's on a belt, because belts take up slack. But and then this doesn't have to be so big. And I still don't know how to mount the motor. So then the motor, I guess, like the motor turns 90. Well, give me 180. No, 90 because that's the front. So then it comes down here, and then we gear this motor. Is that what you're trying to say? So then we end up with like basically we have to have another gear in here. We could cut a valley in this, like we cut this bigger. Like we can cut that bigger and cut a big slot in it. Is that what you're trying to say, or? Because with these Acme gears, they're probably the best gears. I don't understand these. So are you talking like a big gear on the wheel or a little gear? Like what's, and then we come in here like, I'm not sure I understand. And the reason why we're clear is we want no interference with the teeth of the screw, right? There is bevel gears, I think. I will have to find them. But again, now you're asking me to make a transmission or a differential. So that's a whole new, that's totally a new project to what I'm doing. Right, because the differential is spur gears, I believe. Bevel gears. Yeah, there is bevel gears. Hold on. There's a bevel gear right there. So then you'd have to make like an output shaft with a universal joint on it because your alignment's not going to be perfect. Well, it could be, I guess. But if it's not, it'll wear out the motor. And then you basically have to build a differential off of these gears, which you can do, but I don't know. I haven't done any of the math for it, right? Yeah, conic metric gear. Yeah, that's what I have right here. And then you have to figure out the math ratios for it. This was not. So you need something like that. And then you have to have. So then this goes like this. And then I think you need to separate those so you can have a third one. And then you need to know the tooth engagement value. Because you can't start it, like you can't have it like this. It has to be. It has to be something like that, and then you'd have to assemble it. But I don't know what the I don't know what the mesh would be. And I don't know if it's a 1-to-1 ratio or a 3-to-1 ratio or what, right? So we went from building the pulley, which is pretty straightforward, right? Because you do the ratios, because like depending on the diameter of this shaft relative to this shaft depends on how fast it moves, right? And I think the ratio is like 1.25. I know, Mayhem. They're working me hard for not like what am I? I'm having soup for dinner. Working me hard. Oh, I might have vegetable kebabs. And then what I could do. No, because that motor's in the way. And now the motor is touching that plate, so I need to change that plate. And the motor can't touch the plate. It's got to float. So how thick is that? 1 mil? So the plate's not thick enough. So then now this pulley's too long. and the band will walk off it. But what's nice about that is we can just come in here and like cut this down, right? But my concern was that rotation in there. No, I don't need the same gear ratios. I need to know what the ratio is, though. I need to know the diameter of the inner sector. Sorry, I need the inner diameter of the sprocket. Then I need the outer diameter. Then I need to know what the mesh ratio is. Then I need to know my alignment, which is easy enough to establish. Um, and then I need to know what I want to do for um, um, I need to know what my I need to know, like, yeah, I need to know all the. I gotta sit down and draw it. When you do pulleys, pulleys are easy because pulleys are a ratio, right? The diameter of the pulley versus the diameter of something else. But right now, it's like a dead project because even if it does work, it doesn't work because it just goes. So, but yeah, if you guys want me to do gear ratios, I'll just have to spend a day like relearning gear ratios. But like, I think like I agree with you guys. I think that the motor can be in the back because we have a couple of models where it has space to fit, and I can keep adjusting that shank length on the pulley. But if you want to do if you want me to do gear ratios, I have to design a gearbox. Just like if you guys want gear, like if you want something on there and you don't want to use a pulley, I have to do a gearbox. But I have to go into my books and like look at it all because I'm not sure. No, you can have the gear ratio change. Like you can have 62 teeth to 12 teeth. It's fine, but you just have to know what the mesh value is. I don't think this is going to fit, is it? I think I screwed the math up on this one. Maybe not. Oh no, it fits. So there's our output, right? And that will fit a rubber band. And we can turn something over here. Yeah, so we're 58 mil bare minimum between centers. Something like that. So, so we'll do the mount first and see. What's the distance of the mesh from tooth to tooth, right? What's the distance gap between the two? Like I said, I gotta go look at my books because I don't know. And if you guys want to do it, go right ahead. Hop on it. The kit, all the mathematics on the kit are available. So I got to check my alignments, right, for my screw holes to mount it. Then I have my motor mount and my pulley. And then from there, I can hook up a on-off switch, but it just drives in a straight line. Well, relatively straight line. If I really wanted, what I would do is I put bearings in there or something and support the hubs via bearings. All right, man, then show me. Yeah, go ahead and show me. I see. I have this thing where it's like I don't care what anyone molds, right? So this is my on-off switch. Yeah, so I need my mount for this, then I need that. Then I need to mount the hub. So I have on-off switch. I have power reserve I can get from AA or whatever. And I can do the LEDs, that's not a big deal. But yeah, just getting it to drive that axle. Unless I do a drive shaft. Which then I need universal joints, top bottom. And then I need to go into a differential. I have to design a differential. Yeah. Because like if I go into here, yeah. So like then this is nothing. Then this doesn't mean anything. So we abandon this if we're gonna do gears because this is not used in gears. Because then what we would do is we would instead get rid of this. Well, I guess we can use that. We take this, get rid of this, just delete this. Oops, I probably should save that. Delete this, delete this, turn this and this. Can we magnet this? And then rotate. Yeah, we take all of this away. Take this over here. And then we turn this. So this then turns. And then turn this. And then that sits dead. No, not center. So then this comes down. And you try to make that parallel with the output. And then you have a universal joint here that goes to a drive shaft, which then goes into a differential. I believe. Which now we're too small for this motor. Can we rotate? Yeah, we could do it if we cut out a big chunk of the body. Like that. And then you have a drive shaft on two universal joints, one from here and one here, and then you put a differential into the axle. I think. Because you can't go. Yeah, so you can't. You could go. Yeah, you can't go too low because that's where the front end meets with the gap. You can go further forward if you want, and then just have a hole in the cab, I guess. And then you run your power down to the side or whatever, and then into your bus bar, and then you have the battery above the bus, which is all sitting above the drive shaft, which then goes into the axles. I think that would be my guess. And then you design a matching differential, and that gives you your turn ratio of, so you have your spur gear come in. Yeah, I don't know. I've never done this before. But yeah, if it's an easy module, go ahead and show me. Like, build it, show me, and then I'll see what I can do. I've never designed a differential before. And that didn't come out. Probably go to a smaller screw, though. Oh, maybe it'll go. Hone, maybe? So that puts our screw into the shaft, right? So that it won't turn. Because the other one had a little bit of slop in it, but this one is a little bit tighter. Problem is like, because the PLA is so flexible, it will actually contort out of shape. That looks good. And then I need the on-off switch. Is that how it works? Controls on the hot side, motors on the cold side? That's power, so then this... No, what am I doing wrong? I had this the other day. I figured it out the other day. We were talking about it. That applies power to the board. Does that mean there's a jumper that goes there? Okay, so there we go. So that's our super slow turning gearbox. And the deforming is getting caught on the screw. So we'll take that screw out. So that gives us rotation. Oh yeah, we're building cool stuff. But now everybody's like, build a gearbox. I'm like, ugh. Originally, my design was all pulley activated. That that's not super strong. We'll do the mount, and then we'll see what we can turn. The other option is to do a wheel, right? So like what I was going to do originally was going to do a wheel that did an in-out action. But yeah, my brain hurts now. But yeah, so I guess we're not doing the pulley version anymore. We're gonna go and make a gearbox. So I have to go and read my manuals tonight and see if I can come up with a gearbox for Friday, I guess. Something like that. And now people want to put Arduino control onto it, so because like right now it's just gonna turn, right? But this pulley should work on this motor as well. But 400 RPM is a hell of a lot faster than 25 RPM. So it's gonna rip. Oh no, this is geared. So to do this, we make a gear, because that's what you guys want is a gear. Yeah, I don't know. I'll have to go look, I guess. Anyway, I am completely burnt out. We didn't really build anything today. Oh well. But yeah, it was a great show. We did so many sort of what are they? Nothing burgers. But we're getting there. We're doing stuff and things and stuff. So yeah, I just want to say thank you to everybody for tuning in. There's no rating here on YouTube, sadly. Um, yeah, so I will try to figure out a way to make a gearbox so we can turn it, I guess. And then we'll go from there, I guess. Um, yeah. So again, nothing burger day, but fun to play with all the parts that come from the Bambu set. I'm not super happy with this pulley, but like it's that project's dead, so yeah, I I'll see what I can do. But I just want to say thank you for everyone tuning in. I hope you had a great day. I hope you got the likes and the shares and everything available. Remember, subscribe to the channel, and yeah, like working through challenges is always a fun thing to do. So yeah, be safe and have a great night, everybody. Remember, there's 3 things I need to ask you. 1, keep your chin up. You can't see the world if staring at your feet. 2, protect your neck. You don't want to lose your head. And 3, just build, build, build. I love you all very much. Please be safe.
Well, that's it. I really hope you enjoyed it. We had a ball making it. Thank you very